Imagine that the universe has a secret it does not announce. Not a secret buried in equations or locked inside a particle accelerator somewhere, but a secret written across the entire sky, hiding in plain sight, visible to anyone who looks long enough and carefully enough to notice what is actually there. The secret is not about what the universe contains. It is about what the universe removes, what it separates, what it places so far from everything else that the distance itself becomes the defining fact of existence. And the longer you look, the more you begin to suspect that the universe was never really full of things. It was always at its core a vast and growing emptiness, with a thin, luminous residue of matter clinging to the edges of an absence so enormous that no single mind has ever fully held it. And if you want to keep following questions like this, questions that begin in the darkness and lead beyond the limits of ordinary understanding, subscribe to Beyond the Universe, because the farther we look, the less certain the universe becomes. These are the kinds of questions that pull us past the boundary of ordinary understanding, into territory where the answers are more unsettling than the questions. If you find yourself drawn to that edge, you are already in the right place. This is Beyond the Universe. Start with what you know. Start with the night sky as it appears to a human being standing on the surface of this planet, looking up. On a clear night, far from city lights, the sky appears crowded. Stars press against each other in the field of vision. The Milky Way stretches overhead like a river of frozen light, dense and continuous, suggesting a cosmos that is generous with its contents, a universe that has scattered brilliance in every direction without restraint. You might look at that sky and feel instinctively that the universe is full, that it is abundant, that wherever you point your gaze, something is there. That feeling is one of the most profound illusions in the history of human perception. The night sky does not show you the universe. It shows you a narrow slice of your immediate cosmic neighborhood, filtered through the limited sensitivity of human eyes, compressed by the geometry of looking outward from a single point. The stars you see with the naked eye are, in cosmic terms, practically on top of you. The most distant star visible without a telescope is still within our own galaxy, and our galaxy, for all its apparent grandeur, is a single structure among hundreds of billions of others, separated from its nearest neighbors by distances that make the word far feel embarrassingly inadequate. But even before we leave the galaxy, even before we begin to measure the distances between stars, there is something worth sitting with, something that the brightness of the night sky tends to obscure. The space between those stars is not merely large, it is almost entirely nothing. Not nothing in the philosophical sense, not a void waiting to be filled, but a near-perfect absence of matter, of warmth, of any physical interaction whatsoever. If you were to travel from our sun to the nearest star system, Alpha Centauri, a journey of roughly 4 light-years, you would spend the overwhelming majority of that trip surrounded by a vacuum so complete that the human body, unprotected, would cease to function within seconds. There would be no landmarks, no reference points, no sensation of movement, just the slow recession of one light source behind you and the imperceptibly slow brightening of another ahead. 4 light-years. That is the distance to our nearest neighbor, and in that entire span, there is almost nothing. A few stray atoms per cubic meter, the occasional dust grain drifting on no particular trajectory, the faint pressure of light from distant sources. That is all. The space between stars is not a corridor. It is an ocean with no water, no current, no floor, and no shore visible in any direction. You would not notice it at first if you were somehow transported into that interstellar void. The stars would still be visible, the sky would still appear populated, but the appearance would be deceiving because what you would be seeing is not proximity. It would be the accumulated light of objects separated from you by distances that no human technology has ever crossed, and none currently planned could cross within a human lifetime, or 1,000 human lifetimes. The stars in the sky are not neighbors. They are signals from an enormous loneliness, arriving at your eye after years or centuries of travel, giving the false impression of company. This is where the story begins to shift, not with a dramatic revelation, but with a quiet recalibration of what the universe actually is. Because once you accept that the space between stars is almost entirely empty, you are forced to ask a harder question. If the space between individual stars is this vast and this vacant, what does that mean for the space between galaxies? What does it mean for the space between galaxy clusters? What does it mean for the regions of the universe where, for reasons that cosmologists are still working to fully understand, almost no galaxies formed at all? The answer to that question is where the real unease begins. Let us stay for a moment with the solar system. Because even here, even in the small warm corner of the galaxy that we call home, the emptiness is already staggering. The sun sits at the center of a gravitational domain that extends, in some definitions, nearly 2 light-years in every direction. Within that domain, there are 8 planets, dozens of moons, millions of asteroids, billions of comets, and an uncountable number of smaller bodies drifting through the outer reaches. By the standards of human geography, this sounds like a crowded place. It is not. If you were to shrink the sun to the size of a grapefruit and place it on a table, the nearest planet, Mercury, would be a grain of sand roughly 3 meters away. Earth would be another grain of sand about 8 meters from the grapefruit. Jupiter, the largest planet in the solar system, would be a small marble approximately 40 meters distant. Neptune, the outermost major planet, would be a tiny bead nearly 1/4 of a kilometer away. And the nearest star, on this same scale, would be another grapefruit sitting somewhere in Asia or North America, depending on where you placed the first one. Between these 2 grapefruits across that entire continental distance, there would be almost nothing. A few microscopic specks, a handful of atoms, the rest would be void. This is the solar system. This is our home. And it is, by volume, almost entirely empty space. The planets are not scattered through the solar system the way furniture fills a room. They are isolated objects suspended in an enormous vacuum, held in their orbits, not by proximity to anything but by the invisible reach of gravity across distances that dwarf anything in human experience. The solar system does not feel full because it is full. It feels full because we live on one of its objects and have named all the others. The naming creates a false sense of density. The reality is absence, punctuated by rare and temporary islands of matter. Now move outward, leave the solar system behind, and enter the galaxy proper. The Milky Way contains somewhere between 200 billion and 400 billion stars, depending on how you count the faint, dim ones that are difficult to detect. That number is genuinely difficult to hold in the mind. If you counted 1 star per second without stopping, it would take more than 6,000 years to count them all. The galaxy is, by any human measure, an almost incomprehensible collection of suns, and yet the Milky Way is mostly empty. The average distance between stars in the galaxy is several light-years. In the densest regions near the galactic center, stars are closer together, but even there the distances between them are measured in fractions of a light-year, which still means trillions of kilometers of vacuum between each one. If you were to remove all the stars from the Milky Way and compress the remaining empty space, the actual matter in the galaxy would fit into a volume that is a tiny fraction of the galaxy's total size. The galaxy is not a solid structure. It is not even a loosely packed one. It is a pattern of rare, isolated fires burning in an enormous dark room, separated from each other by distances that light itself takes years to cross. From a distance, the Milky Way looks like a solid disk of light. That appearance is an artifact of perspective, of the way light accumulates along lines of sight when you look through a thin layer of stars. It is the same reason a fog appears solid from a distance but reveals itself as mostly air when you walk into it. The galaxy is a fog of stars, and like all fogs, it is mostly the space between the particles, but it goes deeper. Even the stars themselves, those burning points of light that seem so solid and permanent from our vantage point, are not the dense, continuous objects they appear to be. A star is a sphere of plasma, held together by gravity and kept from collapsing by the outward pressure of nuclear fusion at its core. But the atoms inside a star are not packed tightly together. They are in a state of violent, energetic motion, separated from each other by distances that are enormous relative to the size of the atoms themselves. Matter, at the atomic scale, is also mostly empty. The nucleus of an atom is so small relative to the electron cloud surrounding it that if you scaled an atom up to the size of a football stadium, the nucleus would be a marble sitting at the center of the field. The rest of the stadium would be empty space. This is not a metaphor designed to make you feel small. It is a structural fact about the nature of matter. The solidity you feel when you touch a surface is not the result of matter being packed tightly together. It is the result of electromagnetic forces between electron clouds repelling each other. You are not touching anything, in the deepest sense. You are feeling the resistance of one electromagnetic field against another. The matter itself is almost entirely void. So here is where we stand. Before we have even left the galaxy, the space between planets is almost entirely empty. The space between stars is almost entirely empty. The galaxy itself is almost entirely empty. And the matter that does exist within the galaxy is, at the atomic level, almost entirely empty. Emptiness is not the exception in the universe. It is the overwhelming rule. Matter is the exception. Light is the exception. Warmth is the exception. Everything that makes the universe seem inhabited and alive is a rare deviation from a baseline of absence, and this leads to something more disturbing. Because if emptiness is already this dominant at the scale of our own galaxy, what happens when we zoom out further? What happens when we look at the universe not as a collection of stars and galaxies, but as a large-scale structure, a map of everything that exists across the full observable volume of the cosmos? What does the universe look like when you pull back far enough to see not individual galaxies, but the patterns they form, the arrangements they fall into, the shapes that emerge when you treat each galaxy as a single point of light in a much larger picture? The answer is both beautiful and deeply unsettling. The universe, at its largest scales, is not a uniform distribution of matter. It is not a smooth, even spread of galaxies filling space in all directions. It is something far stranger. Galaxies are not scattered randomly through the cosmos. They are arranged along enormous structures, filaments and sheets and walls of matter that stretch across hundreds of millions of light years, forming a pattern that cosmologists call the cosmic web. This web is one of the most remarkable structures in the known universe. It is also one of the most revealing. The cosmic web looks, in large-scale simulations and in the actual observational data gathered by galaxy surveys, like a three-dimensional network of threads. Galaxies cluster along these threads, concentrated at the nodes where filaments intersect, forming the great galaxy clusters and superclusters that represent the densest concentrations of matter in the observable universe. The filaments themselves are not solid structures. They are loose associations of galaxies and gas, stretched across the cosmos by the combined effects of gravity and the expansion of space. And between the filaments, between the walls and sheets and clusters, there is something else entirely. There are the voids, not voids in the casual sense of the word, not simply regions with fewer galaxies. The voids of the cosmic web are enormous, three-dimensional chambers of near emptiness, regions where the density of matter is so far below the cosmic average that they represent a kind of cosmic negative space, the places where the universe failed to gather itself, where gravity never won, where the expansion of space carried matter away before it could accumulate into anything lasting. Some of these voids span tens of millions of light years. The largest known voids span hundreds of millions of light years. They are not gaps in the cosmic web. They are the dominant feature of it. Think about that for a moment. The cosmic web, the large-scale structure of the universe, is not primarily defined by its filaments and clusters. It is primarily defined by its voids. The matter, the galaxies, the stars, the light, all of it is concentrated into a thin, interconnected network of threads and nodes that occupies a small fraction of the total volume of the observable universe. The rest, the vast majority of the space that exists, is void. The universe is not a web of matter floating in space. It is a web of emptiness, with thin threads of matter tracing its edges. From where you stand on the surface of a planet orbiting a star in a galaxy that sits along one of those filaments, the universe appears populated. The sky appears full. The cosmos appears to be a place where things exist. But if you could somehow step outside the filament, if you could move yourself into the interior of one of those great voids and look outward, the universe would look almost unrecognizable. The sky would be darker. The galaxies visible to you would be fewer, fainter, more distant. The sense of cosmic company that the night sky provides, even the faint, abstract sense of it, would be diminished almost to nothing. You would be inside the universe, but the universe would feel absent. There is a particular void that cosmologists have studied with some attention, a region in the direction of the constellation Eridanus, sometimes called the cold spot void, associated with an anomalously cold region in the cosmic microwave background radiation. This void is estimated to span roughly 1 billion light years. 1 billion light years of space in which the density of matter is significantly below the cosmic average. If a civilization existed somewhere inside that void, looking outward with the most powerful telescopes imaginable, the universe would appear to them as a much lonelier place than it appears to us. The nearest galaxy clusters would be far more distant. The cosmic web would be visible only at its edges. The sky would be darker in a way that is not merely aesthetic but cosmological, a genuine reduction in the number of observable objects, a universe that appears, from that vantage point, to be running out of things. That is not a poetic exaggeration. That is a geometric consequence of position. And this is the first layer of the contradiction that runs through everything we are going to explore. The universe appears full because we happen to live in a relatively dense region of it. We are on a filament. We are near a cluster. We are surrounded by the cosmic web structure rather than its absence. Our perception of the universe as a place teeming with galaxies and stars and light is, in part, a function of our address. Change the address, and the universe changes with it, not its actual contents, but its apparent contents. The sky you see is not the sky. It is the sky from here, but it gets worse. Because even the matter that we can see, even the galaxies and stars and gas clouds that make up the luminous structure of the cosmic web, even all of that visible, detectable, measurable material represents only a fraction of what the universe actually contains. The matter that emits light, the matter that we can observe directly with telescopes and detectors, the matter that makes up every star, every planet, every nebula, every galaxy, every human being who has ever lived. All of it together accounts for only about 5% of the total energy content of the universe. 5%. The rest is something else. Something that does not emit light, does not absorb light, does not interact with electromagnetic radiation in any way that our instruments can currently detect. Something that is present everywhere, that shapes the structure of the cosmos, that holds galaxies together and determines the architecture of the cosmic web, but that remains, despite decades of searching, entirely invisible to direct observation. And beyond even that, there is something stranger still, something that is not matter at all, not even invisible matter, but a property of space itself, a tendency of the vacuum to push outward, to expand, to grow, to separate everything from everything else at an accelerating rate. We will come to those things. We will follow this story into its deeper and more disturbing layers. But for now, stay with the 5%. Stay with the recognition that everything you have ever seen, everything that has ever been photographed by a telescope, everything that has ever been detected by any instrument in the history of science, is a thin, luminous residue floating inside a cosmos whose true composition remains, in the most fundamental sense, unknown. The universe is not hiding its secrets in exotic locations. It is not concealing them in black holes or in the cores of distant galaxies. The secrets are everywhere. They are in the space between galaxies. They are in the structure of the cosmic web. They are in the expansion of space itself. They are in the future that the universe is moving toward, a future that the physics we understand suggests will be colder, darker, emptier, and more silent than anything that has existed before. But before we go there, before we follow the story into the darkness that lies ahead, we need to understand the darkness that is already here, the darkness that is not the absence of light, but the presence of something we cannot see, the darkness that holds the universe together while remaining completely invisible, the darkness that is, in a very real sense, the majority of what the universe is made of. To understand that, we need to go back to the cosmic web. We need to look not just at where the galaxies are, but at why they are there. Because the filaments and clusters of the cosmic web did not form randomly. They did not emerge from a uniform distribution of matter simply because gravity pulled things together over time. The structure of the cosmic web, the specific pattern of its filaments and voids, the particular arrangement of its clusters and walls, was shaped by something that the visible matter alone cannot account for. The galaxies we see are not the architects of the cosmic web. They are the decoration on a structure that was built by something else, something that has never been seen. The history of how we came to understand this is itself a kind of detective story, a slow accumulation of evidence pointing toward a conclusion that no one initially wanted to accept. In the middle of the 20th century, astronomers studying the rotation of galaxies noticed something that did not fit. The stars in the outer regions of spiral galaxies were moving too fast. According to the laws of gravity, stars far from the center of a galaxy should orbit more slowly than stars near the center, just as the outer planets of the solar system orbit the sun more slowly than the inner ones. But the observations showed something different. The outer stars were moving at roughly the same speed as the inner ones, or in some cases even faster. The rotation curves of galaxies were flat when they should have been declining. There were two possible explanations. Either the laws of gravity were wrong at galactic scales, which was a possibility that some researchers explored seriously, or there was more mass in the galaxies than the visible matter could account for. Mass that was not shining, mass that was not emitting any detectable radiation, mass that was present only as a gravitational influence, a silent weight pulling on the visible stars and gas without announcing itself in any other way. The evidence for the second explanation accumulated from multiple independent directions. The way galaxy clusters bend light, a phenomenon called gravitational lensing, revealed mass concentrations far greater than the visible matter could explain. The temperature and distribution of hot gas in galaxy clusters pointed to gravitational wells deeper than the luminous matter could create. The large-scale structure of the cosmic web itself, the specific pattern of filaments and voids, matched the predictions of models that included large amounts of invisible mass far better than models that did not. The conclusion became unavoidable. The universe contains a form of matter that does not interact with light. It does not shine. It does not reflect. It does not absorb. It simply exists, and it pulls. This is what we call dark matter. And it is not a small correction to the cosmic inventory. Dark matter appears to make up roughly 27% of the total energy content of the universe. That is more than 5 times the amount of ordinary matter. The stars and planets and gas clouds and human beings, all the visible substance of the cosmos, are a minority component. The majority of the matter in the universe is something we have never directly detected, something whose fundamental nature remains one of the deepest unsolved problems in physics. And this leads to something more disturbing. Because if dark matter is the hidden architecture of the cosmic web, if it is the invisible scaffolding on which the visible universe is built, then the structure we see when we look at the cosmos is not the real structure. The filaments of the cosmic web are not primarily made of galaxies. They are primarily made of dark matter, with galaxies forming along them the way frost forms along the edges of a cold window, tracing a pattern that was already there, revealing a shape that existed before the light arrived. The universe we observe is a shadow of a structure we cannot see. The light is the afterthought. The darkness is the foundation. From where you stand looking up at the night sky, you are seeing the luminous surface of something much larger and much darker. The stars are not the universe. They are the universe's visible fraction, the small percentage of its mass that happens to interact with light. The rest of the universe, the dark matter halos surrounding every galaxy, the dark matter filaments threading through the cosmic web, the dark matter concentrations at the cores of galaxy clusters, all of that is present, all of it is real, all of it is shaping the motion and distribution of everything you can see. But none of it is visible, none of it announces itself. It is simply there, in the way that a current is there beneath the surface of a river, invisible from above but determining everything about where the water goes. The universe is not what it appears to be. It never was. The appearance of a cosmos filled with light and matter is a local, temporary, partial view of something whose true nature is darker, emptier, and stranger than the view from here suggests. And we have not yet reached the strangest part. We have not yet confronted the force or the property or the phenomenon that is not merely shaping the universe but actively pulling it apart. We have not yet looked directly at the thing that is making the emptiness grow. That is where this journey is going. And the further we go, the more the universe will reveal itself not as a place of abundance, but as a place of accelerating loss. Not a cosmos filling up with complexity and light, but a cosmos in the process of separating itself from itself, piece by piece, galaxy by galaxy, horizon by horizon, until the distance between things becomes so great that the things themselves become, in every meaningful sense, alone. The night sky still looks full, the stars still burn, the galaxies still turn. But the story of what the universe is actually doing, the story of where it is going and what it is becoming, is a story that the light does not tell. The light is old news. The light is a message from a universe that no longer exists in the form it had when the light was sent. The universe you are looking at when you look at the night sky is a universe of the past, a collection of signals from sources that have moved, changed, dimmed, or in some cases ceased to exist entirely in the time it took their light to reach you. The present universe, the universe as it actually is right now, is already further away than the light can show you. And the future universe, the universe that the physics of expansion and entropy is building toward, is further still. It is a universe in which the night sky will be darker, in which the galaxies will be fewer, in which the distances will be greater, in which the silence will be deeper, and in which the question of whether anything remains to observe it all will have an answer that no one from our current position in time can find entirely comfortable. There is a region of space that cosmologists refer to informally as the Boötes void. It sits in the direction of the constellation Boötes, roughly 700 million light-years from Earth, and it spans approximately 330 million light-years across. To put that in terms that carry some weight, if the Milky Way were placed at one edge of the Boötes void, and you wanted to reach the other side, you would need to travel 330 million light-years. At the speed of light, that journey would take 330 million years. And for the overwhelming majority of that journey, you would see almost nothing. Not a sparse scattering of galaxies, not a thin distribution of stars, almost nothing. The void contains a small number of galaxies near its edges, but its interior is, by the standards of the observable universe, essentially empty. When astronomers first mapped this structure in the 1980s, some of them reportedly struggled to accept what the data was showing. Not because the data was ambiguous, but because the void was so much larger than existing models of cosmic structure predicted it should be. The universe, according to the theoretical frameworks of the time, should not have had enough time since the Big Bang to produce an empty region that large. The void seemed to violate expectations about how quickly matter could be redistributed by gravity. It was, in a sense, too empty, too large, too absent. Later work refined the measurements and adjusted the theoretical models, and the Buddha's void, while still remarkable, was eventually incorporated into the broader understanding of cosmic structure. But the initial discomfort it produced was not irrational. It was a reasonable response to confronting a scale of emptiness that the human mind is genuinely not equipped to process intuitively. 330 million light-years of near nothing. A chamber in the cosmic web so vast that the entire observable history of complex life on Earth could fit inside it thousands of times over, and still the chamber would be empty. But the Buddha's void is not unique. It is not even the largest void we have identified. The cosmic web is riddled with voids of comparable or greater size. The Hercules Corona Borealis Great Wall, one of the largest known structures in the observable universe, is defined partly by the enormous voids that surround it. The KBC void, a region of below-average density that some researchers believe our own local group of galaxies sits within, may span more than 2 billion light-years. If that interpretation is correct, we are not merely near the cosmic web. We are inside one of its absences, looking outward at the denser filaments and clusters that surround us from a position of relative emptiness. You might think that living inside a void would be obvious, that the sky would look different, that the relative scarcity of nearby galaxies would be immediately apparent. But it is not obvious, because the scale of the void is so enormous that even from within it, the filaments and clusters at its edges appear as distant structures in the sky, indistinguishable in their apparent position from any other distant cosmic feature. The void does not announce itself. It is simply the space you are in, and the space you are in looks, from the inside, like the universe. This is one of the more quietly unsettling implications of large-scale cosmic structure. The universe does not come with a map. It does not provide a legend that tells you where you are relative to the voids and filaments. You have to infer your position from the distribution of what you can see, and that inference is difficult, uncertain, and dependent on instruments and methods that have only existed for a few decades. For most of human history, the question of where we sit in the large-scale structure of the universe was not merely unanswered, it was unasked, because the scale of the structure was entirely unknown. And this matters, because position in the cosmic web is not merely a geographic fact, it is a fact about what you can see, what you can know, and what the universe looks like from where you are. A civilization born inside a deep void, far from any filament, would look out at a sky with far fewer galaxies than we see. Their cosmology would be built on a sample of the universe that is less representative than ours. Their conclusions about the large-scale structure of the cosmos might be systematically wrong in ways they could not easily detect, because the data available to them would be biased by their position in a region of below-average density. And this leads to something more disturbing, because if position in the cosmic web affects what a civilization can observe, and therefore what it can know, then the question of how representative our own position is becomes genuinely important. We believe we have a reasonably good view of the large-scale structure of the universe. We believe our galaxy surveys and our cosmological models give us an accurate picture of the cosmos at its largest scales. But that belief is itself based on observations made from a single point in the universe, a point that may or may not be typical. The universe does not guarantee that any given observer has a representative view. It does not ensure that the sample of the cosmos visible from any particular location is an unbiased sample of the whole. The cosmic web is not a uniform structure. It has regions of higher density and regions of lower density. It has filaments and voids, clusters and walls, and the distribution of these features is not random, but is the result of the specific initial conditions of the universe and the specific way that gravity and expansion have acted on those conditions over the past 13.8 billion years. From any given point within this structure, the view is partial, the map is incomplete, and the incompleteness is not merely a technical limitation that better instruments will eventually overcome. It is in part a fundamental consequence of where you are, but it goes deeper. The cosmic web itself, for all its apparent complexity, for all the intricate beauty of its filaments and clusters, and the vast drama of its voids, is not the primary structure of the universe. It is the visible surface of a deeper architecture. The filaments of the cosmic web are not made primarily of the galaxies that trace them. They are made primarily of dark matter, the invisible component that accounts for more than 5 times the mass of all the visible matter in the universe. The galaxies are not the structure, they are the indicators of the structure, the luminous markers of a gravitational framework that exists independently of the light it generates. To understand what this means, consider how the cosmic web formed. In the earliest moments after the Big Bang, the universe was a nearly uniform plasma of matter and energy, hot and dense and almost featureless. Almost, but not quite. There were tiny fluctuations in density, regions where the matter was very slightly more concentrated than average, and regions where it was very slightly less concentrated. These fluctuations were extraordinarily small, variations of roughly 1 part in 100,000, but they were the seeds of everything that followed. Over time, gravity amplified these fluctuations. The slightly denser regions attracted more matter, growing denser still. The slightly less dense regions lost matter to their denser neighbors, growing emptier. The process was slow at first, operating over hundreds of millions of years, but it was relentless. The denser regions collapsed into filaments and sheets. The less dense regions expanded into voids. The matter in the universe was sorted over billions of years into the pattern we observe today, a cosmic web of filaments and clusters surrounded by enormous voids. But here is the critical point. The dark matter did not follow the visible matter into this structure. The visible matter followed the dark matter. The dark matter, because it was more abundant and because it did not interact with radiation in the early universe the way ordinary matter did, began forming its gravitational structures earlier. It built the scaffolding first. The ordinary matter, the gas that would eventually form stars and galaxies, fell into the gravitational wells that the dark matter had already created. The galaxies formed where the dark matter told them to form. The cosmic web is, at its foundation, a dark matter web. The luminous structure we observe is a secondary phenomenon, a consequence of the primary structure that we cannot see. This reframing changes the meaning of the cosmic web. When you look at an image of the large-scale structure of the universe, when you see those beautiful filaments of galaxies stretching across the darkness, you are not seeing the structure of the universe. You are seeing a faint, luminous echo of it. The real structure is invisible. It is the dark matter halo surrounding every galaxy, the dark matter filament threading through every cosmic web strand, the dark matter concentration at the core of every galaxy cluster. The light is the afterglow of a process that was driven by something that has never emitted a single photon. And the voids, those enormous dark chambers between the filaments, are not simply regions where the dark matter is absent. They are regions where the dark matter lost. Where the initial density fluctuations were too small to overcome the expansion of space. Where gravity was not strong enough to pull matter together before the universe grew too large and too diffuse for collapse to occur. The voids are the places where the universe tried to build structure and failed. They are the scars of a process that succeeded everywhere else. Enormous wounds in the cosmic web where the architecture never arrived. From inside a void, you would be surrounded by the evidence of that failure. The dark matter density would be low. The galaxy density would be low. The gravitational environment would be weak. And the expansion of space would be, in a subtle but measurable way, slightly faster than average, because the reduced gravitational pull of the void's sparse matter would offer less resistance to the expansion. Voids expand. They grow. They push the filaments at their edges further apart over time. The cosmic web is not a static structure. It is a dynamic one, and the dynamics are not moving toward greater density and complexity. They are moving toward greater separation and greater emptiness. But it gets worse, because the expansion of the voids, the growth of the empty regions at the expense of the dense ones, is not merely a consequence of the initial conditions of the universe and the action of gravity over time. It is being driven, accelerated, amplified by something that operates at a level deeper than the cosmic web, deeper than dark matter, deeper than the distribution of galaxies and filaments and voids. It is being driven by something that is not matter at all, not even invisible matter, but a property of space itself. Something that was not predicted by the original models of cosmic expansion. Something whose discovery, in the late 1990s, changed the meaning of the universe in a way that cosmologists are still working to fully absorb. In 1998, 2 independent teams of astronomers were studying a particular type of stellar explosion called a Type Ia supernova. These explosions are useful to cosmologists because they have a known intrinsic brightness, which means that by measuring how bright they appear from Earth, you can calculate how far away they are. The teams were using these supernovae as distance markers to measure the expansion rate of the universe at different points in its history. with the expectation of finding that the expansion was slowing down. Gravity, after all, should be pulling matter together, decelerating the outward rush of the Big Bang over time. The expectation was not unreasonable. It was, in fact, the prediction of the standard cosmological models of the time. What they found instead was the opposite. The distant supernovae were fainter than they should have been, not dramatically fainter, but measurably, consistently, undeniably fainter. And fainter meant further away than expected. And further away than expected meant that the universe had expanded more than the models predicted in the time since those supernovae exploded. The expansion of the universe was not slowing down, it was speeding up. The universe is accelerating. This discovery earned its principal investigators the Nobel Prize in Physics in 2011, and it remains one of the most consequential and most disturbing findings in the history of cosmology, because an accelerating expansion requires an explanation. Something must be driving it. Something must be providing the energy that overcomes the gravitational pull of all the matter in the universe and pushes space itself to expand at an ever-increasing rate. And that something, whatever it is, accounts for roughly 68% of the total energy content of the universe. 68%, more than 2/3 of everything the universe contains, in terms of energy, is this unknown accelerating force. The visible matter, the stars and galaxies and gas clouds, is 5%. The dark matter is 27%. And this third component, this driver of accelerated expansion, is 68%. The universe is dominated energetically by something we do not understand, something we have given the name dark energy because we needed to call it something, and because the name at least acknowledges that it is dark in the sense of being unknown, and energetic in the sense of doing work on the universe at the largest scales. But the name is almost misleading, because dark energy does not behave like energy in the conventional sense. It does not flow from one place to another. It does not concentrate in dense regions. It does not diminish as the universe expands. In fact, the most widely accepted model of dark energy, the one that fits the observational data most closely, treats it not as a substance at all, but as a property of space itself. In this model, empty space has an intrinsic energy density, a baseline energy that is present everywhere, in every cubic meter of vacuum, regardless of what else is or is not in that volume. This is sometimes called the cosmological constant, a term that Einstein introduced and then famously abandoned, and that the universe appears to have reinstated without asking anyone's permission. If this model is correct, then the implications are extraordinary. It means that as the universe expands, as the volume of space increases, the total amount of dark energy increases with it. More space means more dark energy. More dark energy means faster expansion. Faster expansion means more space. The process is self-reinforcing. The universe is not merely expanding. It is expanding in a way that generates the conditions for its own further expansion. The emptiness is not passive. It is productive. It creates more of itself. And this leads to something more disturbing. Because if dark energy is a property of space, if it is intrinsic to the vacuum rather than something added to it, then it cannot be turned off. It cannot be depleted. It cannot be overcome by any concentration of matter, no matter how dense, because it is not competing with matter on matter's terms. It is operating at the level of the geometry of space itself, at the level of the metric that determines how distances are measured and how they change over time. The expansion driven by dark energy is not matter moving through space. It is space itself growing, stretching, increasing the distance between every pair of points that are not gravitationally bound to each other. This distinction matters enormously. When we say that galaxies are moving away from us, we do not mean that they are traveling through space the way a rocket travels through space. We mean that the space between us and them is growing. The galaxies themselves may be nearly stationary relative to their local environment, but the fabric of space that separates them from us is expanding, adding distance between us at a rate that depends on how far away they already are. The further a galaxy is, the faster the space between us, and it is growing, not because distant galaxies are moving faster, but because there is more space between us and them, and all of that space is expanding simultaneously. At a certain distance, the rate at which space is expanding between us and a distant galaxy exceeds the speed of light. This is not a violation of relativity, because nothing is moving through space faster than light. It is the space itself that is growing faster than light can cross it, and this means that beyond a certain distance, light emitted by a galaxy today will never reach us. The space between us and that galaxy will grow faster than the light can travel, and the light will never close the gap. That galaxy is, in a very precise and physical sense, beyond our reach, not merely far away, unreachable, permanently and irrevocably separated from us by the expansion of space itself. That boundary, the distance beyond which light emitted today can never reach us, is called the cosmic event horizon. It is not a wall. It is not a physical barrier. It is a geometric consequence of the expansion rate of the universe, and it is shrinking. As the expansion of the universe accelerates, as dark energy drives space to grow faster and faster, the cosmic event horizon moves closer to us. The volume of the universe from which we can ever receive new information is decreasing. The universe is not opening up as it expands, it is closing down. The observable universe, the region from which light can still reach us, is becoming a smaller and smaller fraction of the total universe. You might think that this is a distant, abstract concern, that the cosmic event horizon is so far away, currently estimated at roughly 16 billion light-years, that its existence has no practical consequence for anything happening in the universe today. And in the immediate term, you would be right. The galaxies currently beyond our event horizon are not ones we have any relationship with. Their light has never reached us. Their existence has never influenced our history. Their disappearance beyond the horizon is, in the present moment, undetectable. But the present moment is not the only moment that matters. The universe has a future, and that future is long, incomprehensibly long. And in that future, the consequences of the cosmic event horizon will become not abstract but absolute. Galaxies that are currently within our observable universe, galaxies whose light we can see today, galaxies that are part of our cosmic neighborhood in the broadest sense, will eventually cross beyond our event horizon. Their light will redshift and fade, their signals will stretch and weaken, and then they will be gone, not destroyed, not ended, but permanently beyond reach, separated from us by an expanding space that no signal, no matter how powerful, can ever cross. The universe is in the process of erasing its own connections, not violently, not suddenly, but steadily, relentlessly, one galaxy at a time, one horizon crossing at a time. The cosmos is separating itself from itself. The web of light and information that currently connects the observable universe is being cut, thread by thread, by the expansion of space, and the cutting is accelerating. But it goes deeper, because the isolation that dark energy is creating is not merely physical, it is epistemic. It is a form of cosmic forgetting. When a galaxy crosses beyond our event horizon, we do not merely lose the ability to travel there, we lose the ability to receive any new information from it. Any event that occurs in that galaxy after it crosses the horizon, any star that forms or dies, any civilization that rises or falls, any signal that is sent in our direction, will never reach us. The information will exist, in the sense that it will be encoded in the physical state of the universe, but it will be encoded in a region of the universe that is permanently inaccessible to us. It will be, from our perspective, as if it never happened. And this is not a one-way problem. From the perspective of a civilization in that distant galaxy, we will also have crossed beyond their horizon. They will also be unable to receive new information from us. The separation is mutual. The universe is not merely moving things apart. It is severing the channels through which things can know about each other. It is creating regions of the cosmos that are not merely distant, but informationally isolated. Regions that cannot communicate with each other even in principle. Regions that are in the deepest sense alone. The cosmic web, that intricate structure of filaments and voids that we spent so long examining, is a snapshot of a universe that is in the process of dissolving its own connections. The filaments are real. The clusters are real. The gravitational bonds that hold galaxies together within a cluster are real, and they will persist even as the universe expands, because gravity within a bound system is strong enough to resist the expansion of space. The Milky Way and its neighbors in the local group will remain gravitationally bound to each other for the foreseeable future. They will eventually merge into a single large elliptical galaxy, a process already underway in the slow gravitational dance between the Milky Way and the Andromeda Galaxy. But beyond the local group, beyond the gravitational reach of our immediate neighborhood, the expansion of space will win. The galaxy clusters beyond our local supercluster will recede. The filaments connecting them to us will stretch and thin and eventually become meaningless as the galaxies at their ends move beyond our horizon. The cosmic web, as a connected structure, will dissolve, not because the matter in it disappears, but because the space between its components grows faster than any signal can cross it. The web will become a collection of isolated islands, each one surrounded by an expanding void that no light can bridge. From inside one of those islands, The future universe will look very different from the universe we see today. The sky will be darker, the number of visible galaxies will be smaller, the cosmic microwave background radiation, the faint afterglow of the Big Bang that currently fills the sky in every direction, will have redshifted to wavelengths so long that it will be undetectable by any instrument we can currently imagine. And the evidence for the Big Bang itself, the observational data that tells us the universe had a beginning, that it was once hot and dense and uniform, will have faded or disappeared entirely. A civilization that arises in the far future, after the expansion of the universe has carried most galaxies beyond the horizon, will look out at a sky that contains only the stars of their own galaxy, and perhaps a few gravitationally bound neighbors. They will have no way of knowing that the universe once contained hundreds of billions of other galaxies. They will have no way of detecting the cosmic microwave background. They will have no way of measuring the expansion of the universe, because the galaxies whose recession velocities would reveal that expansion will be gone. They will build their cosmology on the evidence available to them, and that evidence will point toward a universe that is static, isolated, and eternal. Their best science will lead them to conclusions that are profoundly wrong, not because they are less intelligent or less careful than we are, but because the universe will have hidden its own history from them. The universe is not merely expanding, it is erasing the evidence of its own past. It is moving toward a state in which its own origin story becomes unrecoverable, in which the data needed to reconstruct the Big Bang no longer exists within any observable region. The cosmos is becoming amnesiac, and the process is already underway. We are living in what some cosmologists have called a privileged moment in cosmic history, a window of time in which the universe is still young enough and the expansion still slow enough that the evidence of the Big Bang remains visible. That window will not remain open forever. It is closing, slowly but certainly, driven by the same dark energy that is accelerating the expansion of space. But it gets worse. Because the isolation created by dark energy and the expanding horizon is only the beginning of the story of cosmic loss. Beyond the horizon, beyond the separation of galaxies and the erasure of cosmological evidence, there is a deeper process at work, a process that operates not on the scale of the observable universe but on the scale of time itself, a process that does not merely separate things from each other but gradually exhausts the capacity of the universe to do anything at all. A process that has been operating since the first moment of the universe's existence, and that will continue operating long after the last star has burned out and the last black hole has faded. That process is entropy, and to understand what it means for the fate of the universe, we need to understand what it means for the structure of the cosmic web, for the galaxies within it, and for the stars that make those galaxies visible. We need to follow the story of the universe not just outward in space but forward in time, into a future so remote that the numbers involved lose their meaning, and the only thing that remains is the direction, toward less, toward quieter, toward darker, toward a universe that is not destroyed but exhausted, not ended but emptied of the capacity to sustain the kind of complexity and energy flow that makes observation, memory, and meaning possible. The cosmic web, as it exists today, is a structure in the middle of its story. The filaments are still forming. New stars are still being born in the gas clouds that thread through the galaxies. The universe is still, in a limited and declining sense, productive. But the rate of star formation has already peaked. It reached its maximum roughly 10 billion years ago, in a period cosmologists call cosmic noon, when the universe was young and dense and rich in the cold gas that collapses to form stars. Since then, the rate of star formation has been declining. The universe is making fewer new stars than it once did. The fires are not going out all at once. They are simply not being replaced as quickly as they burn down. This is the beginning of the long dimming. Not a sudden darkness, but a gradual, irreversible decline in the total luminosity of the universe. The stars that exist today will burn for varying lengths of time depending on their mass. The most massive stars burn brightest and die fastest, exhausting their fuel in millions of years. The smallest stars, the red dwarfs that make up the majority of stars in the galaxy, burn so slowly and so dimly that they will persist for trillions of years. But even they will eventually exhaust their fuel. Even the most patient star is not eternal, and when the last star burns out, the universe will enter a phase of darkness that has no precedent in its current history. The cosmic web will still exist, in a sense. The dark matter halos will still be there. The gravitational structures will still be present, but the galaxies within them will be dark. The filaments will be invisible. The voids will be indistinguishable from the regions that once contained stars, because both will be equally dark, equally cold, equally empty of the light that currently makes the cosmic web visible. The universe will not have ended. It will simply have gone dark. And in the darkness, the remaining structures, the dead stars, the black holes, the cold remnants of what were once galaxies, will continue to move and interact, but without the light that would make those interactions observable to any hypothetical watcher. The question of whether there will be any watchers at that point is one we will return to. But for now, stay with the image of the darkening cosmic web. Stay with the recognition that the structure we see today, the filaments and clusters and the luminous galaxies that trace them, is a temporary phenomenon. It is the universe in a particular phase of its history, a phase defined by the presence of stars, by the conversion of nuclear fuel into light and heat, by the existence of the kind of energy gradients that make complex chemistry and biology possible. That phase is not permanent. It is not even, on cosmic timescales, particularly long. It is a brief, bright interval in a much longer story, whose dominant theme is not light but darkness, not complexity but simplicity, not structure but dissolution. The universe is not building toward something. It is not moving toward greater complexity, greater organization, greater meaning. It is moving, as the second law of thermodynamics has always insisted it must, toward greater entropy, toward a state of maximum disorder, minimum energy gradient, and minimum capacity for change. The cosmic web is not the destination. It is a waypoint, a temporary arrangement of matter and energy that exists because the universe has not yet had time to reach its final state. And the final state, the state toward which all of this is moving, is not a dramatic conclusion. It is a quiet, cold, nearly featureless expanse of space in which almost nothing happens, almost nothing changes, and almost nothing remains of the intricate, luminous, briefly inhabited universe that we currently occupy. That is where we are going, and the path there is longer and stranger and more disturbing than any simple description of it can convey, because between now and that final state, the universe will pass through phases that are themselves remarkable and unsettling, phases in which the dominant objects are not stars, but their remnants, not galaxies but their ghosts, not the cosmic web, but its skeleton, phases in which the universe is still doing something, still changing, still evolving, but doing so in ways that are increasingly alien to the conditions that gave rise to us. The story of those phases and of what they mean for the possibility of observation, memory, and meaning in the universe is the story we are moving toward, and it is a story that begins not with the death of stars, but with the nature of the darkness that is already here, already present, already shaping the future that the universe is building for itself in the silence between the filaments of the cosmic web. There is a question that sits underneath everything we have discussed so far, a question that the physics keeps circling without quite answering. We have talked about dark matter as the invisible scaffolding of the cosmic web, the hidden architecture that shaped the distribution of galaxies and filaments and voids. We have talked about dark energy as the accelerating force driving the expansion of space. But we have not yet asked the question that makes both of these things genuinely disturbing, rather than merely mysterious. The question is not what they are. The question is what it means that we do not know what they are. Consider the position we are in. We have built telescopes that can detect light from galaxies more than 13 billion light-years away. We have mapped the cosmic microwave background radiation with extraordinary precision, measuring temperature fluctuations of millionths of a degree across the entire sky. We have detected gravitational waves from colliding black holes a billion light-years distant. We have landed instruments on other planets, sent probes beyond the edge of the solar system, and developed a theoretical framework for the universe that correctly predicts an enormous range of observations. By any reasonable measure, our understanding of the cosmos is the most sophisticated that any known intelligence has ever achieved, and yet 95% of the universe is made of things we do not understand. Not things we have not yet measured precisely, not things we understand in principle but lack the instruments to detect, things we do not understand at a fundamental level, things whose nature, whose composition, whose relationship to the physics we do understand, remains genuinely unknown. Dark matter has been inferred from its gravitational effects for decades, and in all that time, despite numerous experiments designed to detect it directly, despite searches in deep underground laboratories shielded from cosmic rays, despite observations at particle accelerators, despite careful analysis of gamma-ray signals from regions where dark matter should be concentrated, we have not directly detected a single dark matter particle, not one confirmed signal, not one unambiguous detection. This does not mean dark matter does not exist. The gravitational evidence for it is overwhelming and comes from too many independent directions to be dismissed. But the failure to detect it directly means that whatever dark matter is, it interacts with ordinary matter even more weakly than our most sensitive instruments can currently measure. It is not merely invisible. It is almost entirely non-interactive, passing through ordinary matter the way a ghost passes through a wall, leaving no trace, no signal, no mark of its passage. The universe is threaded through with a substance that shapes everything and touches nothing, and dark energy is stranger still. At least dark matter is matter, in the sense that it has mass and gravitational influence. Dark energy is not matter. It is not a particle or a field in the conventional sense. The leading model treats it as a property of the vacuum, an energy intrinsic to empty space. But this creates a problem that physicists find deeply uncomfortable. When they try to calculate the energy density of the vacuum using quantum field theory, the answer they get is wrong by a factor of somewhere between 10 to the power of 60 and 10 to the power of 120, depending on the assumptions made. That is not a small discrepancy. That is the largest discrepancy between a theoretical prediction and an observed value in the history of physics. The theory predicts a vacuum energy so enormous that the universe should have expanded to nothing in an instant after the Big Bang. The observed value is almost incomprehensibly smaller. Something is canceling out almost all of the predicted vacuum energy, leaving only a tiny residue, and we have no idea what that something is. This is not a minor technical problem awaiting a routine solution. It is a sign that our understanding of the relationship between quantum mechanics and gravity, between the physics of the very small and the physics of the very large, is fundamentally incomplete. The universe is accelerating its expansion under the influence of something that our best physical theories cannot correctly predict. We know it is there. We know what it is doing. We do not know what it is. But it goes deeper, because the mystery of dark energy is not merely a problem for theoretical physics. It is a problem for the future of the universe. If dark energy is a cosmological constant, a fixed property of the vacuum that does not change over time, then the expansion of the universe will continue to accelerate at a steady rate, and the future will unfold roughly as we have described: galaxies receding beyond the horizon, the cosmic web dissolving into isolated islands, stars burning out, entropy rising, the universe growing cold and dark over incomprehensible timescales. That future is disturbing enough, but there are other possibilities. Some models of dark energy treat it not as a constant, but as a dynamic field, one that can change in strength over time. In some of these models, the dark energy weakens over time, and the expansion of the universe eventually slows and reverses, leading to a big crunch in which all matter collapses back together. In other models, the dark energy strengthens over time, driving the expansion to accelerate faster and faster, until the expansion rate becomes so extreme that it tears apart not just the connections between galaxies but the connections between atoms, ripping the fabric of space on smaller and smaller scales in an event called the Big Rip. In this scenario, the universe does not fade quietly into darkness. It is torn apart, structure by structure, galaxy by galaxy, star by star, planet by planet, molecule by molecule, atom by atom, until even the subatomic particles are shredded by the expansion of space. We do not know which of these futures is correct. The current observational data is consistent with a cosmological constant, with dark energy that is not changing over time. But the measurements are not precise enough to rule out the dynamic models. The universe's fate is, in a very real sense, unknown. We are living inside a story whose ending we cannot read, driven by a force we cannot identify, toward a destination we cannot determine. And this leads to something more disturbing, because the uncertainty about dark energy is not the only uncertainty about the future. There is another unknown that sits at the boundary between what we know and what we can only speculate about, an unknown that concerns not the expansion of the universe, but the stability of the matter within it. The proton, the positively charged particle at the core of every atomic nucleus, is, as far as we can tell from observation, stable. We have never observed a proton spontaneously decaying into lighter particles. Experiments designed to detect proton decay have run for decades without a confirmed signal. The proton appears to be permanent, but some theoretical frameworks, particularly certain versions of grand unified theories that attempt to unify the strong, weak, and electromagnetic forces into a single framework, predict that protons are not truly stable. They predict that protons decay, but with a half-life so enormous that the probability of observing a single decay in any reasonable experiment is vanishingly small. The predicted half-life of the proton, in some of these models, is on the order of 10 to the power of 34 years or longer. For comparison, the current age of the universe is roughly 10 to the power of 10 years. The proton, if these models are correct, is stable on any timescale relevant to human experience or even to the current age of the universe. But on the timescales of the far future, on the timescales over which the universe will continue to exist after the last stars have burned out, proton decay, if it occurs, would mean that ordinary matter itself is temporary. The atoms that make up planets and dead stars and the remnants of galaxies would slowly dissolve, their protons decaying into lighter particles, their structure dissolving into radiation and leptons over timescales that make the current age of the universe look like an instant. We do not know if protons decay. The experiments have not found evidence for it, but the theoretical motivation for expecting it is not trivial, and the implications, if it is correct, are profound. It would mean that matter, ordinary matter, the 5% of the universe that we can see and touch and measure, is not a permanent feature of the cosmos. It is a temporary arrangement, a phase that the universe passes through on its way to something else, something in which even the cold remnants of dead stars have dissolved into a thin gas of particles and radiation, drifting through an expanding void with no structure, no complexity, and no capacity for anything we would recognize as an event. But even if protons do not decay, even if ordinary matter is stable on arbitrarily long timescales, the future of the universe is not one of preservation. It is one of transformation into forms that are increasingly alien to the conditions that currently exist. And the dominant objects in that transformation, the structures that will outlast stars and galaxies and perhaps even the protons themselves, are the objects that already represent the most extreme concentrations of matter and gravity in the current universe, the objects that form when stars die in the most violent way possible, the objects that have already consumed enormous quantities of matter and that will continue to grow and persist long after everything else has gone dark. Black holes. A black hole is not simply a very dense object. It is a region of space where the curvature of spacetime has become so extreme that nothing, not matter, not light, not any signal of any kind, can escape from within a certain boundary called the event horizon. Whatever crosses that boundary is, from the perspective of the outside universe, gone, not destroyed in the conventional sense, but removed from the accessible universe, enclosed within a region from which no information can escape. A black hole is, in a sense, the ultimate expression of the universe's tendency toward isolation. It is a place where the separation between inside and outside is absolute and permanent. Black holes form when massive stars exhaust their nuclear fuel and collapse under their own gravity. They also exist at the centers of most large galaxies, including our own, in the form of supermassive black holes with masses millions or billions of times that of the Sun. These supermassive black holes are among the most massive objects in the universe, and they will be among the last structures standing when everything else has gone dark. As stars burn out and galaxies darken, as the cosmic web dissolves into isolated islands, and the expansion of space carries most of the universe beyond the horizon, the black holes will remain. They will continue to grow slowly, by absorbing whatever matter drifts within their gravitational reach. And they will persist for timescales that make the current age of the universe seem negligible. But even black holes are not eternal. In 1974, the physicist Stephen Hawking demonstrated theoretically that black holes are not perfectly black. They emit a faint thermal radiation, now called Hawking radiation, as a consequence of quantum mechanical effects near the event horizon. This radiation carries energy away from the black hole, and over time, the black hole loses mass. The process is extraordinarily slow for large black holes. A black hole with the mass of the Sun would take roughly 10 to the power of 67 years to evaporate completely through Hawking radiation. A supermassive black hole at the center of a large galaxy might take 10 to the power of 100 years or more. These are numbers so large that they are essentially meaningless in terms of human intuition, but they are finite. Given enough time, even the largest black hole will evaporate, radiating its mass away as a faint glow of thermal radiation until nothing remains. And when the last black hole evaporates, what is left? The answer, according to our current best understanding, is very little. A thin, cold, nearly uniform distribution of particles and radiation, spread across an expanding space so vast that the average density of the universe will be almost inconceivably low. Photons from Hawking radiation, drifting apart at the speed of light, electrons and positrons if protons have decayed, or cold remnants of matter if they have not, neutrinos, nearly massless and nearly non-interacting, passing through the expanding void without touching anything. The temperature of the universe will be extraordinarily close to absolute zero, but not quite zero. because the expansion of space itself generates a faint thermal background called the Gibbons-Hawking temperature, a temperature so low that it makes the current cosmic microwave background, already less than 3 degrees above absolute zero, seem warm by comparison. This is the state that physicists call heat death, or the big freeze. Not a dramatic ending, not a collapse or an explosion or a transformation into something new, just a slow, patient, irreversible approach toward a state of maximum entropy, in which the universe contains the same total energy it always has, but that energy is distributed so uniformly, so evenly, so completely without gradient or structure, that no further work can be extracted from it. No engine can run, no chemistry can proceed, no information can be processed, no observation can be made. The universe will be in the most precise thermodynamic sense dead, not absent, not destroyed, simply incapable of doing anything. But it gets worse, because the heat death of the universe is not merely a physical state, it is an epistemic state. It is a state in which not only is nothing happening, but nothing can be remembered. Memory, in any physical sense, requires a system that maintains a stable configuration over time, a system that preserves information against the tendency of entropy to erase it. In the heat-death universe, no such system can exist. The thermal fluctuations that remain will be random, uncorrelated, without pattern or persistence. Any configuration that briefly resembles a memory will dissolve back into randomness before it can influence anything else. The universe will not merely have forgotten its history, it will have become incapable of the kind of physical process that constitutes memory in the first place. This means that the history of the universe, the entire 13.8 billion year story of the Big Bang, and the formation of the first stars, and the emergence of galaxies, and the evolution of life, and the development of intelligence, and the construction of civilizations, and the asking of questions about the nature of the cosmos, all of that history will become, in the far future, physically unrecoverable. Not merely unknown to any observer, but encoded in a physical state so diffuse and so randomized that no process, however sophisticated, could reconstruct it. The universe will have erased itself, not its matter, not its energy, but its story, its meaning, its record of having been something rather than nothing. And this leads to something more disturbing, because the erasure of cosmic history is not something that begins only at the heat death. It is something that is already happening right now, driven by the same expansion of space that is carrying galaxies beyond our horizon. Every galaxy that crosses our cosmic event horizon takes its history with it. Every event that occurs beyond that horizon is an event that we can never know about, never incorporate into our understanding of the universe, never add to the record of what has happened. The universe is not waiting until the heat death to begin erasing itself. It is erasing itself continuously, at the rate of one horizon crossing at a time, one permanently inaccessible event at a time. We are already living in a universe that is smaller than it was yesterday, in the sense that the volume from which we can ever receive information is slightly smaller today than it was yesterday, and will be slightly smaller tomorrow than it is today. The observable universe is not a fixed container. It is a shrinking window, and the rate at which it shrinks is accelerating, driven by the dark energy that is pushing the expansion of space faster and faster. The universe is not merely large, it is becoming less knowable at an accelerating rate. From where you stand, this may seem abstract. The galaxies disappearing beyond the horizon are not ones you have any relationship with. The history being erased is not history that anyone has recorded or cares about. The shrinking of the observable universe is happening on timescales so long that it has no practical consequence for anything in the foreseeable future. But the principle it establishes is not abstract. The principle is that the universe does not preserve its own history. The universe does not maintain a record of what has happened within it. The universe is not a library, it is a process, and the process is one of continuous, irreversible loss. But it goes deeper, because the loss of cosmic history is not merely a consequence of the expansion of space. It is also a consequence of the nature of black holes. When matter falls into a black hole, the information encoded in that matter, the specific quantum state of every particle, the precise configuration of every atom, the complete physical description of whatever fell in, is apparently lost to the outside universe. The black hole retains the total mass, charge, and angular momentum of what fell in, but not the specific information about its internal structure. A book in an equal mass of hydrogen gas, if dropped into a black hole, would produce identical changes in the black hole's external properties. The information that distinguished the book from the gas would be gone. This is the black hole information paradox. one of the deepest unsolved problems in theoretical physics. Hawking's original analysis suggested that the information was permanently destroyed, that the Hawking radiation emitted as the black hole evaporated was purely thermal and carried no information about what had fallen in. This would mean that black holes are not merely gravitational prisons, but information destroyers, objects that take the specific, structured, meaningful configurations of matter and energy and convert them into featureless thermal noise. If this is correct, then every black hole in the universe is a machine for erasing information, and the universe contains hundreds of billions of galaxies, each containing a supermassive black hole at its center, surrounded by millions of stellar mass black holes formed from the deaths of massive stars. The current consensus among physicists leans toward the view that information is not truly destroyed, that it is somehow encoded in the Hawking radiation in a subtle and highly scrambled form, and that the evaporation of a black hole eventually releases all the information that fell into it, albeit in a form so thoroughly scrambled that it is practically unrecoverable. But practically unrecoverable and theoretically recoverable are very different things, and the distinction matters less than it might seem. If the information is released in a form that no physical process can decode, then for all practical purposes it is lost. The universe may be technically preserving its information while making it permanently inaccessible. The library may still exist, but every book in it has been shredded and the pieces scattered across an expanding void. The universe is not a place that remembers, it is a place that forgets, and it forgets not by accident, not through negligence, but through the operation of its most fundamental physical laws. Entropy increases, horizons expand, black holes scramble information, space stretches, the past becomes inaccessible, the future becomes unknowable, and the present, the brief, luminous, structured, complex present in which stars burn and galaxies turn, and minds ask questions about the nature of the cosmos, is a temporary exception to a rule that the universe enforces with absolute consistency. But it gets worse, because even within the present, even within this brief window of cosmic time, in which the universe is still producing stars and light, and the conditions for complexity, the distribution of that complexity is not uniform. The cosmic web concentrates matter in filaments and clusters, leaving the voids empty. Within the filaments, galaxies concentrate matter in their disks and bulges, leaving the intergalactic medium sparse. Within galaxies, stars concentrate matter in their cores, leaving the interstellar medium thin. Within stellar systems, planets concentrate matter in their surfaces and interiors, leaving the space between them nearly empty. At every scale, the universe organizes its matter into rare, isolated concentrations surrounded by vast emptiness. And at every scale, the emptiness is winning. The voids are growing, the filaments are thinning, the galaxies are darkening, the stars are burning out faster than new ones are being born. The universe is not in a steady state. It is in a state of decline. Not a catastrophic decline, not a sudden collapse, but a slow, patient, irreversible decline in the total amount of structure, complexity, and energy gradient that exists within it. The peak of cosmic complexity, the moment when the universe contained the most stars, the most active galaxies, the most vigorous star formation, the most abundant raw material for the emergence of complexity. That moment is already in the past. We are living in the aftermath of the universe's most productive era, in a cosmos that is still rich and active by the standards of what is to come, but that has already passed its peak and is moving, steadily and without reversal, toward a quieter and emptier state. This is not a pessimistic interpretation of the data, it is what the data says. The rate of star formation in the universe has declined by roughly a factor of 10 since cosmic noon, 10 billion years ago. The total luminosity of the universe is lower now than it was then. The fraction of gas available for star formation is lower. The universe is using up its fuel, and the rate at which it is using it up is declining not because the universe is becoming more efficient, but because there is less fuel available. The universe is winding down, and the winding down is not happening uniformly. It is happening faster in some places than others, faster in the dense clusters where star formation has already largely ceased, slower in the outer regions of galaxies where gas is still available and new stars are still forming. But the direction is the same everywhere. The direction is toward less light, less heat, less structure, less complexity, less of everything that makes the universe, from our perspective, interesting. From where you stand, on the surface of a planet warmed by a middle-aged star in a galaxy that is still forming new stars at a modest rate, the universe does not feel like it is winding down. The The sun will continue to burn for another 5 billion years. The Milky Way will continue to form new stars for billions of years beyond that. The local group will remain gravitationally bound and active for tens of billions of years. On any timescale relevant to human experience or even to the entire history of life on Earth, the universe appears stable, productive, and enduring. But the universe does not operate on human timescales. It operates on timescales that make the entire history of life on Earth, 4 billion years of evolution and complexity and change, look like a single frame in a film that runs for trillions of years. And on those timescales, the direction of the universe is unmistakable. It is moving toward a state in which the conditions that gave rise to us, the conditions that make stars and planets and chemistry and biology possible, will no longer exist. Not because something will destroy those conditions, but because the universe will have used them up. The stars will burn out, the galaxies will darken, the black holes will evaporate, the matter will either decay or drift apart, the temperature will approach absolute zero, the entropy will approach its maximum, and the universe will continue to exist in a sense, but it will be a universe in which nothing happens, nothing changes, nothing is remembered, and nothing is possible. A universe that is, in every meaningful sense, over. And this leads to something more disturbing. Because the question of what it means for the universe to be over is not merely a physical question, it is a philosophical one. The universe does not have a perspective. It does not experience its own history or its own future. It does not know that it once contained stars and galaxies and minds that asked questions about its nature. It does not know that those minds existed, or that they are gone, or that the questions they asked will never be answered by anyone. The universe is indifferent to its own story in a way that is not cruel but simply structural. Indifference is not a choice the universe makes. It is what the universe is. But we are not indifferent. We are the part of the universe that is not indifferent. The part that looks outward and asks what is there. The part that measures and models and wonders and worries. And from our perspective, the story of the universe is not merely a physical process. It is a narrative, a sequence of events with a beginning and a middle and an end. A story that has meaning because we are inside it, and because we are capable of recognizing meaning. The question of what happens to that meaning when the conditions for it no longer exist is not a question that physics can answer, but it is a question that the physics makes unavoidable. The universe is not asking us to find comfort in its story. It is not offering reassurance. It is simply doing what it does, expanding and cooling and darkening and separating, following the laws that govern it with perfect consistency and perfect indifference. And the more carefully we look at what it is doing, the more clearly we see that the story it is telling is not one of abundance and permanence, but one of scarcity and loss. Not a universe filling up with light and complexity, but a universe in the process of emptying itself of both. The darkness is not coming. It is already here, in the voids between the filaments in the invisible mass of dark matter, in the accelerating expansion driven by dark energy, in the declining rate of star formation, in the galaxies already beyond our horizon, in the information already lost to black holes, in the entropy already accumulated since the first moment of the universe's existence. The darkness is the condition, the light is the exception, and the exception is temporary. There is a particular kind of loneliness that has no name in any human language, because no human being has ever experienced it directly. It is not the loneliness of isolation from other people, or the loneliness of grief, or the loneliness of being misunderstood. It is the loneliness of a position in space so remote from any other concentration of matter that the concept of elsewhere becomes meaningless. A position where the nearest galaxy is not merely far away, but unreachable in principle, where the expansion of space has made the distance between here and there not a challenge to be overcome, but a permanent and absolute condition, where the universe, in every direction, offers nothing but the slow, cold expansion of a void that has no edge, and no center and no destination. No civilization has ever occupied such a position, but the physics suggests that every civilization that arises in the far future will, not because they will be transported there, not because some catastrophe will scatter them into the void, but because the universe will have moved around them. The galaxies that are currently their neighbors will have receded beyond the horizon. The cosmic web that currently connects their galaxy to thousands of others will have dissolved. The universe will have rearranged itself, through the patient operation of dark energy and the expansion of space, into a configuration in which every gravitationally bound island is surrounded by an expanding emptiness that no signal can cross. The loneliness will not arrive as an event, It will arrive as a gradual realization that the universe has become smaller, and then smaller still, and then finally, irrevocably, just this. But before we follow the universe into that future, before we trace the full arc of what is coming, we need to sit with something that the previous parts of this journey have been building toward without quite stating directly. We have talked about dark matter as invisible architecture. We have talked about dark energy as accelerating expansion. We have talked about cosmic voids as the dominant feature of the large-scale structure. We have talked about the declining rate of star formation and the eventual heat death of the universe. But we have not yet asked the question that connects all of these things into a single, coherent, deeply unsettling picture. The question is this: what is the universe actually doing? Not in the sense of what physical processes are occurring. We have described those. The question is what the universe is doing in the sense of what direction it is moving, what state it is approaching, what the sum of all its processes adds up to when you step back far enough to see the whole. And the answer, when you look at it clearly, is not what the night sky suggests. The night sky suggests a universe that is doing many things simultaneously, a universe of activity and variety and change. But the large-scale view, the view from outside the filament, the view from the far future, the view that takes into account not just the present moment, but the full trajectory of cosmic history, suggests something different. The universe is doing one thing. It is separating. Everything else, the formation of stars, the evolution of galaxies, the emergence of complexity, the brief flowering of life and intelligence in certain corners of certain galaxies, all of it is a local, temporary deviation from the dominant process. The dominant process is separation. Matter separating from matter as the voids grow. Galaxies separating from galaxies as the expansion of space carries them apart. Observable regions separating from each other as the horizon shrinks. Energy separating from usable form as entropy increases. Structure separating from itself as the gradients that maintain it are slowly erased. The universe is, at its largest scale and over its longest timescales, a machine for producing separation, and it is running that machine faster and faster. This reframing changes the meaning of everything we have discussed. The cosmic web is not a structure the universe built. It is a structure the universe is in the process of dismantling. The filaments and clusters are not the universe's achievement. They are its residue, the temporary concentrations of matter that formed during a brief period when gravity was strong enough to compete with expansion, before dark energy tipped the balance permanently in expansion's favor. The galaxies are not the universe's purpose. They are its leftovers, the matter that managed to bind together before the expansion carried it too far apart to collapse, now drifting in their isolated gravitational islands as the space around them grows, and the stars within those galaxies, those burning points of light that make the night sky seem full and the universe seem inhabited, are not the universe's gift to complexity. They are the universe's way of spending its remaining reserves of order. Every star that burns is converting a structured, low-entropy configuration of hydrogen into a less structured, higher entropy configuration of helium and heavier elements and radiation. Every photon that a star emits is a small increment of entropy, a small step toward the heat death, a small contribution to the universe's relentless progress toward maximum disorder. The light is not the universe giving, it is the universe spending, and the account is finite, but it goes deeper, because the spending is not merely physical, it is also informational. Every process that occurs in the universe, every collision between particles, every chemical reaction, every gravitational interaction, every quantum event generates entropy, and in doing so degrades the information content of the universe. Not in the sense that information is destroyed, if we accept the view that black holes eventually return their information in scrambled form, but in the sense that information becomes increasingly inaccessible, increasingly scrambled, increasingly impossible to decode or use. The universe is not losing its information, it is losing its ability to do anything with its information. The library is not burning. The books are being translated into a language that no possible reader can understand. This distinction between information existing and information being accessible is one of the most important and least discussed aspects of the universe's fate. We tend to think of information as either present or absent, either preserved or destroyed. But the thermodynamic reality is more subtle and more disturbing. Information can exist in a physical system while being completely inaccessible to any process within that system. A gas of particles in thermal equilibrium contains, in principle, the complete information about the initial state of every particle that contributed to it. But that information is encoded in the precise positions and velocities of an enormous number of particles, correlated in ways so complex and so sensitive to initial conditions that no physical process could ever decode it. The information is there. It is simply, for all practical and most theoretical purposes, gone. The universe is moving toward a state in which all of its information is in this condition, present but inaccessible, encoded but unreadable, existing but meaningless. A universe in which the complete history of everything that has ever happened is, in principle, written into the physical state of the cosmos, but written in a script so scrambled, so diffuse, so thoroughly mixed by billions of years of entropy increase that no reader, no matter how powerful, could reconstruct a single sentence of it. That is not a universe that has ended. That is a universe that has become a perfect and permanent silence. And this leads to something more disturbing. Because the silence is not merely the absence of sound, it is the absence of the conditions that make meaning possible. Meaning, in any physical sense, requires a difference. It requires a system that can distinguish between states, that can respond differently to different inputs, that can maintain a record of past states and use that record to influence future behavior. In thermodynamic terms, meaning requires a gradient. It requires a difference in energy, in temperature, in concentration, in some physical quantity that can drive a process, power a computation, sustain a structure. Without gradients, there is no work. Without work, there is no process. Without process, there is no change. Without change, there is no time in any meaningful sense. No before and after. No cause and effect. No story. The heat-death universe is a universe without gradients. It is a universe in which every difference has been smoothed away, every gradient has been erased, every source of usable energy has been spent. It is a universe in which the concept of meaning has no physical substrate, not because meaning has been destroyed, but because the conditions that allow meaning to exist have been permanently and irreversibly eliminated. The universe will not have become meaningless. It will have become a place where meaningfulness is no longer a possible property of anything. From where you stand, this is a long way away. The sun will not exhaust its fuel for another 5 billion years. The Milky Way will continue to form stars for billions of years beyond that. The local group will remain active for tens of billions of years. The last red dwarf stars will burn for trillions of years. The black holes will persist for timescales that dwarf all of that. The heat death is not imminent. It is not even, by any reasonable measure, soon. It is simply inevitable. And inevitability, when the thing that is inevitable is the permanent elimination of the conditions for meaning, is its own kind of weight. But let us not rush to the end. Let us stay for a moment in the middle of the story. Let us look at the universe as it will be not in the far future, but in the intermediate future, in the era after the last stars have burned out, but before the last black holes have evaporated. This era, which cosmologists sometimes call the degenerate era, is a phase of the universe's history that will last far longer than the current stelliferous era, the era of stars in which we currently live. The degenerate era will be dominated not by stars but by their remnants, white dwarfs, neutron stars, and black holes. White dwarfs are the cooling embers of stars like our sun. When a star like the sun exhausts its nuclear fuel, it will shed its outer layers as a planetary nebula and leave behind a dense hot core of carbon and oxygen, roughly the size of Earth but with a mass comparable to the sun. This white dwarf will not be fusing anything. It will simply be cooling, radiating away the heat it accumulated during its life as a star, growing dimmer and cooler over billions of years. Eventually, over timescales of quadrillions of years, it will cool to the temperature of the surrounding space and become a black dwarf, a cold, dark, inert sphere of crystallized carbon and oxygen, drifting through the void without emitting any light. There are currently no black dwarfs in the universe. The universe is not old enough for any white dwarf to have cooled completely. The oldest white dwarfs in the Milky Way are still warm enough to be detectable, but in the far future, the universe will be populated by an enormous number of these cold, dark remnants, the crystallized corpses of stars that once burned, drifting through the expanding void in the gravitational islands that were once galaxies. They will not interact with each other in any energetically significant way. They will not produce light. They will not generate heat. They will simply be there, cold and dark and patient, as the universe continues to expand around them. Neutron stars are the remnants of more massive stars, objects so dense that a teaspoon of their material would weigh billions of tons, objects where the protons and electrons of ordinary matter have been crushed together into neutrons by the extreme pressure of gravitational collapse. They are among the most extreme objects in the current universe. spinning rapidly, emitting beams of radiation, generating gravitational waves when they collide. But in the far future, they too will cool and slow and darken, becoming cold, dense spheres of neutron matter drifting through the void alongside the black dwarfs and the black holes. And the black holes will be the last active structures in the universe. Not active in the sense of doing anything dramatic, but active in the sense of still changing, still evaporating through Hawking radiation, still slowly losing mass and growing smaller. The supermassive black holes at the centers of what were once galaxies will be the last objects in the universe to undergo any significant physical process. Their evaporation will be the last event in the universe's history that could, in principle, be observed. And when the last one evaporates, when the last quantum of Hawking radiation disperses into the expanding void, the universe will enter a state from which no further change is possible. But it gets worse, because even before the last black hole evaporates, even during the long degenerate era when white dwarfs and neutron stars and black holes populate the darkened galaxies, the universe will be doing something that is easy to overlook, but deeply significant. It will be forgetting. Not in the metaphorical sense, but in the physical sense. The information encoded in the structures of the universe, in the specific arrangement of matter and energy that constitutes the history of the cosmos, will be continuously degraded by the processes of entropy increase. The gravitational interactions between cold remnants will slowly randomize their orbits. The quantum fluctuations in the vacuum will slowly alter the states of particles. The Hawking radiation from black holes will slowly scramble the information of everything that fell into them. The universe will be, throughout the degenerate era, engaged in the patient, relentless work of erasing its own past. And there is something particularly striking about the timescale of this erasure. The universe is currently 13.8 billion years old. The stelliferous era, the era of stars, will last perhaps another 100 trillion years, roughly 10,000 times the current age of the universe. The degenerate era, the era of stellar remnants, will last perhaps 10 to the power of 40 years, an incomprehensibly longer span. And the black hole era, the era dominated by evaporating black holes, will last perhaps 10 to the power of 100 years or more. These timescales are so large that they make the entire history of the universe to date, including the formation of the first stars, the evolution of galaxies, the emergence of life, the development of intelligence, the construction of civilizations, all of it, look like the first microsecond of a film that runs for the age of the universe times itself, times itself, times itself. We are, in cosmic terms, at the very beginning. The universe is young. The stars are young. The conditions that allow complexity in life and observation are young. And the overwhelming majority of the universe's future, the vast, dark, cold, empty future that stretches ahead of it, will be a future without any of those things. The brief, bright, complex present is not the universe's story. It is the universe's prologue. And this leads to something more disturbing. Because if the present is the prologue, if the era of stars and galaxies and life and intelligence is a brief opening chapter in a much longer story, whose dominant theme is darkness and silence and entropy, then the question of what the universe is for becomes genuinely difficult to answer. Not in a theological sense, not as a question about divine purpose, but in a purely physical sense. What is the function of the brief, complex, luminous phase of the universe's history in the context of the much longer, darker, simpler phase that follows it? What does the existence of stars and galaxies and minds contribute to the overall trajectory of the cosmos? The honest answer is that it contributes entropy. The stars burn hydrogen into helium and heavier elements, increasing the entropy of the universe. The galaxies concentrate matter and then disperse it, increasing the entropy of the universe. The emergence of life and intelligence, the most complex processes we know of, are also, from a thermodynamic perspective, entropy-generating processes. Life does not decrease the entropy of the universe. It increases it, locally and temporarily, creating order at the cost of generating greater disorder in its surroundings. The complexity of life is not a violation of the second law of thermodynamics. It is a particularly elaborate expression of it. This does not diminish the significance of life or intelligence or the questions they ask, but it does place them in a context that is larger and colder than the context in which we usually consider them. We are not the universe's purpose. We are the universe's process. We are one of the ways in which the universe moves from a state of lower entropy to a state of higher entropy, one of the mechanisms by which the cosmic account of order is spent. And when the account is fully spent, when the entropy has reached its maximum and no further process is possible, we will not be missed. Not because we are unimportant, but because there will be nothing left that is capable of missing anything. But it goes deeper, because the question of observation, of what it means for the universe to be observed, is not merely a philosophical question. It has physical implications that connect directly to the story we have been telling. The universe, as far as we know, does not require an observer to exist. The expansion of space, the formation of galaxies, the burning of stars, the increase of entropy, all of these processes occur regardless of whether any mind is present to observe them. The universe does not need to be seen to be real, but the act of observation, the act of measuring and recording and understanding, is itself a physical process, and it is a process that requires specific physical conditions. It requires a system complex enough to model its environment, stable enough to maintain that model over time, and energetically sustained enough to continue operating. It requires, in short, the kind of conditions that exist in the current universe and will not exist in the far future. An observer is not merely a philosophical concept. An observer is a physical structure that requires energy gradients to function, that requires a difference between hot and cold, between ordered and disordered, between signal and noise. In the heat-death universe, none of those differences exist. There are no observers in the heat-death universe, not because they have been destroyed, but because the physical conditions that make observation possible have been permanently eliminated. The universe will continue to exist in the sense that space will continue to expand, and the thin distribution of particles and radiation will continue to drift apart, but it will exist unobserved, not merely unobserved by any intelligence, but unobservable in principle, because the conditions for observation will no longer be present anywhere within it. A universe that exists but cannot be observed is not a universe in any sense that connects to the concept of a cosmos, a word that originally meant order, arrangement, beauty. The heat-death universe is not a cosmos. It is a residue. It is what remains after the cosmos has spent itself, after the order has been converted to disorder, after the gradients have been smoothed, after the story has been told, and the telling has become impossible. It is the universe after the universe, the space that remains when everything that made it a universe has gone, and the path to that residue is already laid. The expansion is already accelerating. The horizon is already shrinking. The rate of star formation is already declining. The entropy is already rising. The galaxies beyond our horizon are already gone, in the sense that no new information from them will ever reach us. The universe is already, in every direction and at every scale, moving toward the condition that will eventually define it absolutely. The movement is slow. The timescales are incomprehensible, but the direction is fixed. There is no known physical process that reverses entropy on a cosmic scale. There is no known mechanism that could halt the expansion of space or reverse the action of dark energy. There is no known way to reconstruct the information lost to black holes or to recover the history erased by the expansion of the horizon. The universe does not offer a second chance. It does not cycle back. It does not reset. It moves in one direction, and that direction is toward less structure, less light, less heat, less complexity, less information, less observation, less meaning, less of everything that makes the universe from the inside feel like something rather than nothing. But it gets worse, because the most disturbing aspect of this story is not the heat death itself. The heat death is far away, separated from us by timescales so enormous that they have no emotional reality. The most disturbing aspect is what the story implies about the present, about right now, about the universe as it currently exists, with its stars and galaxies and cosmic web, and the thin, temporary, improbable conditions that allow minds to exist within it and ask questions about it. The implication is that the present is not the norm. The present is the exception. The universe we inhabit, the universe of light and structure and complexity and observation, is not the universe's default state. It is a deviation from the default state, a brief, improbable, temporary departure from the baseline condition of cold, dark, empty, structureless space. We exist in the exception. We are made of the exception. We are the exception asking questions about itself. And the exception is ending. Not today, not soon, by any human measure. But the trajectory is clear, and the trajectory does not bend back. The universe is not moving toward more of what we are. It is moving toward less. The conditions that produced us are becoming rarer. The energy gradients that sustain us are being spent. The information that constitutes our history is being scrambled. The space that connects us to the rest of the cosmos is expanding faster than any message can cross it. We are, in the most precise physical sense, being left behind by a universe that is moving on. The night sky still looks full. The stars still burn with the same apparent brightness they had when the first human beings looked up at them. The Milky Way still stretches overhead in its luminous arc. The universe still appears, from the surface of this planet, to be a place of abundance and permanence and light. But the appearance is a local fact, a consequence of our position in a dense region of the cosmic web, in a galaxy that is still forming stars, orbiting a star that is still in the middle of its life. The appearance is true, in the narrow sense that the light is real and the stars are real and the warmth is real, but it is not the whole truth. It is not even the main truth. The main truth is the void between the filaments. The main truth is the dark matter that shapes everything without appearing. The main truth is the dark energy that is pulling the universe apart faster than any force can hold it together. The main truth is the horizon that is shrinking, the entropy that is rising, the stars that are burning out faster than new ones are being born, the galaxies that are already beyond reach, the history that is already being erased. The main truth is that the universe is not a place of abundance. It is a place of accelerating loss, and the abundance we see is the last of what there was. We are reading the universe by the light of fires that are going out, and the fires do not know they are going out. The stars burn with the same indifference they have always had, converting hydrogen to helium, radiating energy into the void, following the laws of physics with perfect consistency and perfect unconcern. The universe does not mourn its own trajectory. It does not resist the increase of entropy or the expansion of space or the crossing of galaxies beyond the horizon. It simply continues, doing what it does, moving in the direction it moves, indifferent to the fact that the direction leads somewhere that no observer will ever see. That indifference is not cruelty. It is simply the nature of a universe that operates by physical law rather than by intention, but from the inside. From the perspective of a mind that has looked carefully at the data and followed the implications to their conclusion, the indifference feels like something. It feels like the universe is a story being told to no one, a process unfolding without witness, a history accumulating without record. It feels like the largest and most complete expression of something that has no name, because the thing it expresses is not a human experience and was never meant to be understood by anything that lives and thinks and wonders. It feels like the universe is alone in a way that nothing inside it can fully comprehend, because the loneliness of the universe is not the loneliness of a thing that wants company and cannot find it. It is the loneliness of a process that has no wants, no needs, no awareness of its own condition, and no capacity to be otherwise. The universe is not lonely, but the universe is the kind of place that produces loneliness, briefly, in the minds of the things it temporarily assembles from its matter and energy, before it disassembles them again and moves on. We are those things. We are the universe's brief capacity for self-awareness, its temporary ability to look at itself and ask what it is. And what it is, when you look carefully enough and follow the implications far enough, is something that the looking makes harder to bear, not because the universe is hostile, not because it is indifferent in a way that is directed at us, but because the universe is simply what it is, and what it is mostly empty, mostly dark, mostly cold, mostly silent and moving, with perfect consistency and perfect indifference toward being more so. There is a thought experiment that cosmologists sometimes use to illustrate the consequences of accelerating expansion, and it goes like this. Imagine a civilization that arises not now, not in the current universe with its hundreds of billions of visible galaxies and its rich cosmic web and its detectable microwave background, but in the far future, after the expansion of space has carried all but the nearest galaxies beyond the horizon. This civilization looks out at its sky and sees a small collection of stars, the remnants of a merged local group, surrounded in every direction by darkness. They build telescopes, they develop physics, they measure the motions of the stars around them, and find no evidence of expansion, because the only objects they can observe are gravitationally bound to them, and therefore not participating in the cosmic expansion. They search for a microwave background and find nothing, because the background has redshifted to wavelengths so long that no instrument they can build will ever detect it. They look for evidence of other galaxies and find none, because there are none within their observable horizon. This civilization will conclude, based on the best evidence available to them, that the universe is a single island of stars surrounded by infinite empty space. They will have no way of knowing that the universe once contained hundreds of billions of other galaxies. They will have no way of knowing that the space around them is expanding. They will have no way of knowing that there was a Big Bang, that the universe had a beginning, that the conditions they inhabit are the remnant of a much larger and more complex cosmic history. Their best science will be wrong in ways they cannot detect, because the evidence that would correct it has been permanently removed from their observable universe by the expansion of space. This is not a hypothetical designed to make us feel superior to an imaginary future civilization. It is a warning about the relationship between observation and truth. The universe does not guarantee that the evidence needed to understand it will remain accessible to any observer at any given time. The universe does not preserve its own history in a form that can be read. It does not maintain a record of what it once was. It simply continues, and the evidence of its past is carried away by its own expansion, scrambled by its own entropy, hidden behind its own horizons. The future civilization is not less intelligent than we are. They are simply later, and being later, in a universe driven by dark energy, means having access to less. We are earlier. We are, in a very specific and important sense, lucky to be here now, in this particular window of cosmic time, when the evidence of the Big Bang is still visible, when the cosmic web is still intact enough to be mapped, when the expansion of the universe is still slow enough that hundreds of billions of galaxies remain within our observable horizon. We are living in the universe's most information-rich era, the era when the most evidence about the most cosmic history is simultaneously accessible from a single point of observation. That era is not permanent. It is not even, on cosmic timescales, long. It is a window, and the window is closing. But it goes deeper, because the closing of the window is not merely a loss of information about the past. It is a loss of the capacity to ask certain questions at all. The question of whether the universe had a beginning. The question of what the large-scale structure of the cosmos looks like. The question of whether there are other galaxies beyond our own. These are questions that we can currently ask and answer because the evidence to answer them is available to us. In the far future, those questions will not merely be unanswerable, they will be unaskable because the concepts they depend on, the concept of a cosmic beginning, the concept of a large-scale structure, the concept of other galaxies, will have no observational basis. The future civilization will not know what they do not know. They will not know that there are questions they cannot ask, because the questions themselves will have been erased along with the evidence that would have motivated them. This is a form of cosmic loss that is more profound than the loss of matter or energy. It is the loss of the possibility of certain kinds of understanding. The universe is not merely becoming emptier, it is becoming less knowable, in a way that is not a limitation of any particular observer's intelligence or instruments, but a fundamental consequence of the physical state of the cosmos. The universe is moving toward a condition in which certain truths about itself are not merely unknown, but unknowable, not merely hidden, but permanently beyond the reach of any possible inquiry. And this leads to something more disturbing, because if the universe is moving toward a condition of permanent unknowability, if the evidence of its own history is being systematically erased by its own physical processes, then the question of what the universe is, in the deepest sense, becomes genuinely open. We believe we understand the broad outlines of cosmic history. We believe we know that the universe began in a hot, dense state roughly 13.8 billion years ago, that it expanded and cooled, that matter formed and gravity shaped it into the cosmic web, that stars and galaxies emerged and evolved, that the expansion is now accelerating under the influence of dark energy. We believe these things because the evidence for them is currently available to us, encoded in the light from distant galaxies, in the cosmic microwave background, in the large-scale structure of the universe. But our understanding is itself a product of our position in time. We are observing the universe from a particular moment in its history, a moment when a particular set of evidence is available. A different moment would yield a different set of evidence and potentially a different understanding. The future civilization with no access to the microwave background and no visible galaxies beyond their own would construct a cosmology that is, by our standards, profoundly wrong. But from their perspective, it would be the best cosmology possible, the one most consistent with all available evidence. They would have no way of knowing it was wrong. And this raises a question that is uncomfortable to sit with. How do we know that we are not in an analogous position? How do we know that the evidence available to us, the evidence from which we have constructed our current understanding of the universe, is not itself a partial and misleading sample of a larger reality that our position in time and space prevents us from seeing? We cannot know this with certainty. We can only work with the evidence we have, construct the best models we can, and acknowledge that our understanding is bounded by our horizon, our instruments, and our moment in cosmic history. The universe may be stranger than we currently know, not in the sense of hidden conspiracies or suppressed data, but in the sense that the physical reality beyond our observable horizon, the reality that the expansion of space has placed permanently beyond our reach, may contain structures, processes, or conditions that would fundamentally alter our understanding of the cosmos. If we could observe them, we cannot observe them. We will never be able to observe them. They are not merely far away. They are beyond the boundary of what is, in principle, knowable from our position. The observable universe is not the universe. It is the universe as seen from here, now, through the window that our position in space and time provides. And the window is smaller than the room. But it gets worse, because the question of what lies beyond the observable horizon is not merely a question about the present universe. It is a question about the initial conditions of the universe, about what the Big Bang produced beyond the region that is currently visible to us. The standard model of cosmology includes a period of extremely rapid expansion in the very early universe, called inflation, during which the universe expanded by an enormous factor in an extraordinarily short time. Inflation is supported by several lines of observational evidence, including the flatness of the universe's geometry and the specific pattern of fluctuations in the cosmic microwave background. But inflation also has a consequence that is deeply strange. If inflation occurred, it almost certainly produced a universe that is vastly larger than the observable portion. The region that inflated into the observable universe was a tiny fraction of the total volume that inflation produced. The rest of that volume, the overwhelming majority of the universe that inflation created, is beyond our horizon and will remain beyond our horizon forever. We cannot observe it, we cannot measure it, we cannot determine whether it has the same physical properties as the observable universe or different ones. We cannot know whether the constants of physics, the values of the fundamental parameters that determine the behavior of matter and energy, are the same in those distant regions as they are here. Some theoretical frameworks suggest that they might not be. In certain models of inflation, different regions of the universe can end up with different values of the physical constants, different amounts of dark energy, different properties of matter. In these models, the observable universe is not a representative sample of the whole. It is one bubble among many, one region among an enormous number of regions, each with its own physical properties, each evolving according to its own version of the laws of physics. The universe we inhabit may be, in this sense, a local accident, a particular set of conditions that happen to arise in our corner of a much larger and more varied cosmos. We cannot confirm this. We cannot rule it out. The evidence that would distinguish between these possibilities is, by definition, beyond our horizon. We are left with a universe whose full extent and full nature are permanently beyond our reach, a universe that may be far stranger and far larger than anything we can observe, a universe whose observable portion may be a deeply unrepresentative sample of the whole. The map we have drawn is not wrong, but it may be a map of a very small room in a very large building, whose other rooms we will never enter, and whose overall architecture we will never see. And this is where the story of cosmic emptiness arrives at its deepest and most unsettling layer. Not the emptiness of the voids between galaxies, not the emptiness of the space between stars, not even the emptiness of the heat-death universe, but the emptiness of knowledge itself, the permanent structural, physically enforced limit on what any observer, anywhere in the universe, at any time in the universe's history, can know about the cosmos they inhabit. The universe is not merely large, it is larger than knowable. It is not merely old, it is older than reconstructible. It is not merely complex, it is more complex than any possible model can capture, because the model is always built from a subset of the evidence, and the subset is always smaller than the whole. The darkness is not only in the voids, it is in the horizon, it is in the limit of observation, it is in the gap between what the universe is and what any observer within it can determine that it is. The universe contains its own unknowability as a structural feature, not as a temporary limitation to be overcome by better instruments or more sophisticated theories, but as a permanent consequence of its own geometry, its own expansion, its own entropy, its own age. But it goes deeper still, because even within the observable universe, even within the region from which light can currently reach us, there are layers of inaccessibility that go beyond the simple question of distance. The cosmic microwave background, the oldest light we can observe, was emitted roughly 380,000 years after the Big Bang, when the universe had cooled enough for electrons and protons to combine into neutral hydrogen, and the universe became transparent to light for the first time. Before that moment, the universe was opaque. Light could not travel freely. The photons were constantly scattered by the dense plasma of charged particles. Whatever happened in the first 380,000 years of the universe's history Whatever processes occurred, whatever structures formed and dissolved, whatever initial conditions were set, is hidden behind the surface of last scattering, the wall of the microwave background beyond which no photon has ever reached us. We can probe the early universe through other means. Gravitational waves, if they were produced in sufficient quantities in the early universe, could in principle carry information from before the surface of last scattering. Neutrinos, which decoupled from the rest of the universe even earlier than photons, form a cosmic neutrino background that in principle encodes information about the universe at 1 second after the Big Bang. But detecting these signals is extraordinarily difficult, and the information they carry is limited. The very earliest moments of the universe, the first fractions of a second after the Big Bang, the period of inflation, the conditions that set the initial state of everything that followed, are hidden behind layers of inaccessibility that our current physics and our current instruments cannot fully penetrate. The universe has a past that it does not fully reveal. It has a present that it reveals only partially, through the narrow window of the observable horizon, and it has a future that it is actively making less knowable, by carrying evidence beyond the horizon, by scrambling information through entropy, by erasing the gradients that make observation possible. The universe is, in every direction and at every scale, retreating from full knowability. It is becoming, with time, more opaque to understanding, not less. And this leads to something more disturbing. Because the retreat of the universe from knowability is not a neutral fact, it has consequences for the meaning of the questions we ask about it. We ask what the universe is made of, and the answer is that 95% of it is something we do not understand. We ask what the universe looks like at its largest scales, and the answer is that most of it is beyond our horizon. We ask what the universe was like in its earliest moments, and the answer is that those moments are hidden behind the surface of last scattering. We ask what the universe will become, and the answer is that the future depends on the nature of dark energy, which we do not understand. We ask whether the universe is all there is, and the answer is that we cannot know, because the rest of it, if there is a rest, is permanently beyond our reach. Every fundamental question we ask about the universe runs into a wall, not a wall of ignorance that more research will eventually dissolve, but a wall of physical limitation, a boundary imposed by the geometry of the cosmos, the speed of light, the expansion of space, the opacity of the early universe, the scrambling of information by entropy. The universe is not withholding its secrets out of hostility. It is simply structured in a way that makes certain secrets permanently inaccessible to any observer within it. The secrets are not hidden, they are gone, or they are beyond reach, or they were never encoded in a form that any possible instrument could read. We are not on the verge of a complete understanding of the universe. We are not approaching a final theory that will answer all the fundamental questions. We are, if anything, becoming more aware of the depth and permanence of our ignorance, more aware of the structural limits on what any observer in any universe can know about the cosmos they inhabit. The more carefully we look, the more clearly we see not just what is there, but what is not there, what has been removed, what has been carried beyond reach, what has been erased by the very processes that make the universe what it is. The universe is not a puzzle waiting to be solved. It is a process moving away from solvability, carrying its own answers with it as it expands and cools and darkens and separates. The questions we ask today are questions that will become unanswerable in the future, not because we will have lost the intelligence to answer them, but because the universe will have removed the evidence. We are asking the questions at the right time, in the sense that this is the time when the evidence is most available, but the right time is also a temporary time. And temporary, in a universe driven by dark energy toward a cold and empty future, means something more final than it sounds. There is a particular image that captures something of what all of this means, not a photograph or a simulation, but a thought. Imagine the last observer in the universe, not the last human being, not the last biological creature, but the last physical system of any kind that is complex enough to constitute an observation, to distinguish between states, to process information, to be, in any meaningful sense, aware of its surroundings. This system exists in the far future, in the degenerate era or the black hole era, surrounded by cold remnants and expanding void. It observes what it can observe, which is very little. It processes what information is available to it, which is almost none. And then, because entropy continues to rise and energy gradients continue to diminish, it ceases to function, not dramatically, not with any announcement. It simply stops, the way a fire stops when the last of its fuel is consumed, without ceremony, without witness, without record. After that, the universe continues. The expansion continues. The entropy continues to rise, though there is almost nothing left for it to act on. The void continues to grow. The last photons of Hawking radiation from the last evaporating black holes continue to disperse into the expanding space. The universe continues to be, in the most minimal sense of the word, something rather than nothing. But it is something that no longer contains anything capable of noticing that it is something. It is existence without observation, process without witness, continuation without meaning. This is not the end of the universe. The universe does not end. It simply becomes a place where nothing happens, where nothing can happen, where the conditions for happening have been permanently and irreversibly eliminated. It becomes the final expression of the emptiness that was always its dominant feature, the emptiness that was present in the voids between the filaments, in the space between the stars, in the vacuum between the atoms, in the gap between what the universe is and what any observer within it can know. The emptiness was always there. In the end, it is all that is there. And this is the thing that the night sky does not tell you. The night sky tells you that the universe is full of light, full of stars, full of the kind of abundance that makes existence feel like a gift rather than an accident. But the night sky is a local view, a temporary view, a view from inside the exception rather than from outside it. The full view, the view that takes in not just the present moment but the full arc of cosmic time, not just the observable horizon, but the structural limits of knowability, not just the light but the darkness that surrounds and pervades and ultimately outlasts it. The full view is different. The full view is of a universe that is mostly empty, that is becoming more empty, that is carrying its own history beyond the reach of any possible observer, that is spending its reserves of order and complexity and light on a trajectory toward a cold and structureless and permanent silence. A universe that produced, briefly and improbably, the conditions for minds to exist within it and ask questions about it, and that is now, with perfect indifference and perfect consistency, in the process of eliminating those conditions forever. The stars are still burning. The galaxies are still turning. The cosmic web is still intact, its filaments still tracing the dark matter scaffolding that shaped them, its voids still growing, its clusters still bound by gravity against the expansion of space. The universe is still, by any measure, an extraordinary place, rich with structure and light and the kind of complexity that took billions of years to produce. None of that is false. None of that is diminished by what we have learned about where it is going. But it is incomplete. The picture of the universe as a place of abundance and permanence and light is incomplete in a way that matters, in a way that changes the meaning of everything within it. The abundance is temporary. The permanence is an illusion created by the shortness of human timescales relative to cosmic ones. The light is the product of a process that is winding down, spending the last of the universe's reserves of order on a trajectory that leads, with mathematical certainty, toward darkness. We are inside that trajectory. We are part of it. We are made of the matter that the universe assembled during its brief, productive, luminous phase, and we are asking questions about the universe using the energy that the universe is spending on its way to exhaustion. We are, in the most literal sense, the universe thinking about itself. And what the universe is thinking, when it thinks carefully enough and follows the implications far enough, is something that does not resolve into comfort or reassurance, or the kind of meaning that makes the thinking feel worthwhile. What the universe is thinking when it thinks about itself is that it is alone, that it has always been alone, in the sense that the vast majority of its volume has always been empty, that the vast majority of its future will be empty, that the connections between its parts are temporary and the separations are permanent, that the light it produces is a brief exception to a baseline of darkness, that the complexity it generates is a temporary deviation from a trajectory toward simplicity, that the observers it creates are transient structures in a process that does not require them and will not preserve them. The universe is not a home. It is a process, and the process is not moving toward anything that resembles home. It is moving toward something that has no name in any human language, because no human being has ever experienced it, and no human being ever will. It is moving toward the condition that the physics describes with perfect precision and perfect coldness: maximum entropy, minimum gradient, zero observation, infinite expansion, permanent silence. The night sky still looks full, but now you know what the fullness is. It is the last of the light, burning in the dark, in a universe that is mostly void, that is becoming more void, that will eventually be nothing but void, expanding forever into a silence so complete and so permanent that the word silence is not adequate to describe it. There is no word adequate to describe it. Because the thing it describes is beyond the reach of any language that any mind in any universe could ever develop. Because the minds and the languages and the universes that could develop them are themselves part of what the silence will have consumed. The darkness is not coming. It was always here. We are the brief, improbable, temporary exception to it. And the exception, like all exceptions, is defined by what surrounds it. What surrounds it is everything. What surrounds it is most of the universe, most of the time, and most of the places that exist and will ever exist. What surrounds it is the void between the filaments, the dark matter that shapes without shining, the dark energy that separates without touching, the horizon that shrinks without announcing itself, the entropy that rises without pause, the future that arrives not as catastrophe but as less and less and less, until the less becomes so complete that the word less no longer has anything to measure itself against. The universe is not ending, it is continuing, and the continuation is the most unsettling part of all, because it is a continuation without witness, without memory, without the possibility of meaning, without anything that the word continuation was ever meant to describe. It is the universe after the universe has finished being a universe, still there, still expanding, still subject to the laws of physics, but empty of everything that made those laws matter to anything. We looked up at the night sky and saw light. We looked closer and found distance. We looked further and found emptiness. We looked deeper and found invisible architecture. We looked ahead and found acceleration. We looked forward in time and found darkness. We looked at the darkness and found that it was not the absence of the universe but its destination, not the background against which the universe exists but the condition toward which it is moving, not the nothing that surrounds the something but the something that the something is becoming. The sky is full of stars. The stars are full of fire. The fire is full of time. And the time is running out, slowly, patiently, irreversibly, in a universe that does not notice and does not care and will not remember, expanding into a silence that has no edge and no end, and no one left to hear it. This is the thing that the physics cannot explain. Not the expansion of space, not the nature of dark energy, not the composition of dark matter, not the fate of information in black holes. Those are difficult problems, but they are problems within the domain of physics, problems that the methods of science are designed to address. The thing that the physics cannot explain is why, given everything we have just described, given the full weight of what the universe is and where it is going, we keep looking. Why we build larger telescopes, why we send probes to the edges of the solar system, why we spend decades designing instruments to detect gravitational waves or map the cosmic microwave background, or search for the signature of dark matter in the depths of underground laboratories. Why we ask the questions at all, knowing that the answers, when they come, do not resolve into comfort. The easy answer is that curiosity is a biological trait, selected for by evolution because organisms that explored their environment survived better than organisms that did not. The easy answer is that science is a social institution, sustained by funding and careers and the human desire for status and recognition. The easy answer is that we look because looking is what we do, because the capacity for inquiry is built into the kind of minds that evolution produced on this particular planet, and we cannot help but exercise it. The easy answer is probably partly true, but it is not sufficient. Because the looking we are describing is not the looking of an organism scanning its environment for food or predators. It is the looking of a mind that has already understood, at least in outline, what it will find. We are not looking because we expect the universe to reveal something that will make us feel better about our situation. We have been looking long enough to know that the universe does not offer that. We are looking at a cosmos that is mostly empty, mostly dark, mostly cold, mostly indifferent, and moving toward a state of permanent silence. We know this, and we keep looking anyway. There is something in that persistence that is worth examining. Not because it changes the physics, not because it alters the trajectory of the universe or delays the heat death or recovers the information lost to black holes. It changes none of those things. But it is perhaps the most interesting fact about the universe that the universe has so far produced. Not the cosmic web, not the dark matter, not the accelerating expansion. The most interesting fact is that the universe, in at least one location, at least one time, produced something that looked back at it and tried to understand it. Something that looked at the darkness and did not look away, because looking away would be easier. The darkness is not comfortable to contemplate. The implications of the physics are not reassuring. The trajectory of the universe does not lead anywhere that any mind would choose to go, and yet the response of the minds that have understood this The response of the cosmologists and physicists and philosophers who have followed the implications to their conclusion has not generally been to stop looking. It has been to look harder, to build better instruments, to develop more precise theories, to push the boundary of the observable further, even knowing that the boundary is shrinking, even knowing that the universe is carrying its own answers beyond the reach of any possible inquiry. This is not heroism. It is not defiance. It is something quieter and stranger than either of those things. It is the behavior of a system that has developed the capacity for understanding and cannot stop exercising that capacity, even when the understanding it produces is not what the system would have chosen to find. It is the universe's brief capacity for self-awareness, operating at full intensity, in the full knowledge of its own impermanence, in the full knowledge of the darkness that surrounds it, and the silence that awaits it. But it goes deeper, because the act of understanding the universe, the act of measuring and modeling and comprehending the cosmos, is not merely a passive reception of information, it is a physical process. It is a process that occurs in the universe, that uses the universe's energy, that is subject to the universe's laws, and as a physical process, it has a relationship to the universe's trajectory that is not merely incidental. The act of understanding is itself an act of entropy generation. Every thought, every calculation, every observation, every model, every theory, every question asked and every answer found generates heat, increases entropy, contributes to the universe's progress toward its final state. The minds that are trying to understand the universe are, in the most literal physical sense, helping to bring about the condition they are trying to understand. This is not a reason to stop thinking. It is not a paradox that undermines the value of inquiry. It is simply a fact about the relationship between minds and the universe they inhabit. Minds are not outside the universe, observing it from a position of detachment. They are inside it, made of it, subject to its laws, participating in its processes. The understanding they produce is real, but it is produced at a cost, and the cost is paid in the currency of the universe's remaining reserves of order. Every insight is purchased with entropy. Every discovery is paid for with the universe's future, and this means that the act of understanding the universe is, in a very precise sense, irreversible, not merely in the sense that you cannot unlearn what you have learned, but in the thermodynamic sense that the entropy generated by the process of understanding cannot be recovered. The heat produced by the computation cannot be converted back into usable energy. The order spent on the act of inquiry cannot be restored. The universe that existed before the question was asked is gone, replaced by a universe that is very slightly more disordered, very slightly closer to its final state, very slightly further along the trajectory that leads to the permanent silence. Every question we ask about the universe moves the universe by an infinitesimal but real amount toward the condition in which no questions can be asked. The inquiry is self-consuming. The understanding is self-erasing. The light that the mind casts on the darkness is itself a form of spending, a drawing down of the universe's account of order, a contribution to the entropy that will eventually make all light and all minds and all questions impossible. But it gets worse, because the self-consuming nature of inquiry is not merely a thermodynamic fact. It is a fact about the relationship between knowledge and time. The universe we are trying to understand is not static. It is changing continuously and irreversibly in ways that make the understanding we achieve at any given moment incomplete by the time we have achieved it. The universe we mapped yesterday is not the universe that exists today. The galaxies have moved, the stars have aged, the expansion has continued, the entropy has risen, the horizon has shrunk. The universe we are trying to understand is always already different from the universe we have understood, always already further along its trajectory, always already slightly more removed from the conditions that made the understanding possible. We are chasing a moving target, not in the sense that the universe is trying to evade us, but in the sense that the universe is a process and processes do not wait. The understanding we achieve is always a snapshot of a system that has already moved on. The map is always of a territory that has already changed. The knowledge is always of a universe that is already, in some small way, gone. And this is the condition of all knowledge, not just cosmological knowledge. All understanding is understanding of something that was, not something that is. The light from the nearest star takes 4 years to reach us. The light from the nearest galaxy takes 2 million years. The light from the edge of the observable universe takes 13 billion years. We are always looking at the past. We are always understanding what was. The present is always beyond our reach, always ahead of the light that carries information about it, always in the process of becoming the past before we can observe it. The universe is not a thing that can be fully known. It is a process that can only be partially and retrospectively understood, from a position inside it, using instruments made of it, at a moment in its history that is itself temporary and unrepresentative of the whole. The understanding we achieve is real. It is not nothing, but it is bounded in ways that are not merely technical, but fundamental, not merely current, but permanent, not merely limitations of our present knowledge, but structural features of the relationship between any possible observer and the universe they inhabit. And this leads to something more disturbing, because if all understanding is partial, retrospective, and bounded by the observer's position in space and time, then the question of what the universe actually is, independent of any observer's perspective, becomes genuinely difficult. We have a model of the universe. It is a good model. It correctly predicts an enormous range of observations. It has been tested against data from telescopes and particle accelerators and gravitational wave detectors and cosmic microwave background maps. It is the best model any intelligence has ever constructed of the cosmos it inhabits, and it tells us that 95% of the universe is made of things we do not understand, that the universe is expanding in a way we cannot fully explain, that the initial conditions of the universe are hidden behind a surface of last scattering we cannot see through, and that the vast majority of the universe is beyond our horizon and permanently inaccessible. The best model we have is a model of our ignorance as much as a model of our knowledge. It is a map that shows with great precision where the edges of the map are. It is an understanding that understands with great clarity the limits of its own understanding. And those limits are not small. They are not minor gaps to be filled in by future research. They are structural features of the universe, permanent consequences of its geometry and its history and its trajectory, walls that no instrument and no theory will ever fully penetrate. We are not approaching the end of ignorance. We are mapping its contours. We are learning with increasing precision the shape of what we do not and cannot know, and the shape is large. The shape is, in fact, larger than the shape of what we do know, larger than the observable universe, larger than the history we can reconstruct, larger than the future we can predict. The darkness is not the background against which our knowledge stands out. The darkness is the majority. The knowledge is the exception, but it goes deeper still, because the darkness is not merely external. It is not merely the darkness of the voids between galaxies or the darkness beyond the horizon or the darkness of the heat-death future. There is a darkness that is internal to the act of understanding itself, a darkness that is not the absence of knowledge, but the consequence of it. The more carefully we look at the universe, the more clearly we see not just what is there, but what is not there. Not just the structure, but the emptiness that surrounds and pervades it. Not just the light, but the darkness that the light is an exception to. The understanding does not illuminate the darkness. It reveals how much of the darkness there is. This is not a failure of understanding. It is its deepest achievement. The ability to see the darkness clearly, to measure it, to map its extent, to understand its nature and its causes and its trajectory, is a more profound form of knowledge than the ability to see only the light. The cosmologist who understands the heat-death of the universe knows something more complete and more honest about the cosmos than the ancient astronomer who saw only the eternal, unchanging stars. The knowledge is harder to bear, but it is more true. And truth, even when it is hard to bear, is not nothing. It is not nothing to have looked at the universe and seen it clearly. It is not nothing to have measured the expansion of space and found that it is accelerating. It is not nothing to have mapped the cosmic web and found that it is mostly void. It is not nothing to have followed the trajectory of the universe to its conclusion and found that the conclusion is silence. These are real achievements of real minds in a real universe, and they are achievements that the universe, in the overwhelming majority of its history and its volume, will never produce again. They are, in the most literal sense, rare. The rarity is not comforting, but it is significant. The universe is not full of minds asking questions about it. It is, as far as we can determine, almost entirely empty of them. The conditions that produce minds are specific and demanding: the right kind of star, the right kind of planet, the right kind of chemistry, the right kind of time. Those conditions exist in some places and not in others, and the places where they exist are a vanishingly small fraction of the total volume of the universe. The minds that arise in those places are a vanishingly small fraction of the matter that the universe contains. And the questions those minds ask, the questions about the nature and origin and fate of the cosmos, are a vanishingly small fraction of the processes that occur within it. We are, by any measure, an improbable exception. Not special in the sense of being chosen or intended or cosmically significant. Special in the sense of being statistically extraordinary, in the sense of being the kind of thing that the universe produces rarely and briefly, and without apparent purpose. The universe did not make us to understand it. The universe did not make us at all, in any intentional sense. We are what happened when the right conditions existed in the right place at the right time, and the right conditions are not common, and the right time is not long, and the right place is a small rocky planet orbiting an ordinary star in the outer arm of a spiral galaxy that is itself a minor feature of a cosmic web that is mostly empty space. And from that small rocky planet in that brief window of time when the conditions for minds existed and the evidence for the universe's history was still accessible, we looked up. We looked up, and we measured, and we calculated, and we modeled, and we understood, imperfectly and partially and retrospectively, something of what the universe is. We found that it is mostly empty. We found that it is mostly dark. We found that it is mostly made of things we do not understand. We found that it is moving toward a state of permanent silence. We found that the evidence of its own history is being systematically erased by its own physical processes. We found that the conditions that allow minds to exist within it are temporary and declining. We found all of this, and we wrote it down, and we told each other about it, and we kept looking. The writing it down matters. Not because the writing will survive forever, not because the records we keep will outlast the stars or the black holes or the heat death, but because the writing is itself an act of the kind that the universe almost never performs. It is the universe encoding information about itself in a form that another part of the universe can read. It is the cosmos, briefly and improbably, achieving a kind of self-knowledge that the overwhelming majority of its volume and its history will never contain. The writing is temporary. The knowledge is temporary. The minds that produce both are temporary. But temporary is not the same as meaningless, even in a universe that is moving toward a state in which the distinction between meaningful and meaningless will no longer apply to anything. But it gets worse, because the writing will not survive, not in any form that any future observer could read. The records we keep, the books and the databases and the scientific papers and the observations encoded in the light curves of distant supernovae and the temperature maps of the cosmic microwave background, all of it is stored in physical systems that are subject to the same entropy that governs everything else. The hard drives will fail, the paper will decay, the stone will erode, the atoms will, if protons decay, dissolve, and even if the physical substrate survives, the context needed to interpret it will not. A future civilization that found our records, if such a civilization were possible, would need to understand our language, our mathematics, our physical theories, our observational methods, our entire intellectual framework, to extract the knowledge encoded in them, and the probability of that context surviving intact across the timescales of the universe's future is, for all practical purposes, zero. The knowledge we have produced will not outlast us by much. It will not be inherited by the universe's future. It will not contribute to any cumulative project of cosmic understanding that persists beyond the conditions that made it possible. It will be produced briefly in this window of time, and then it will be gone, along with the minds that produced it and the conditions that made those minds possible and the stars that powered those conditions, and the galaxies that contained those stars and the cosmic web that shaped those galaxies. All of it together will be gone, not destroyed in any dramatic sense, simply dissolved back into the entropy from which it briefly emerged, leaving no trace that any future process could recover. This is the final implication of the physics. Not merely that the universe is mostly empty, not merely that it is moving toward silence, not merely that the conditions for minds are temporary, but that the understanding those minds achieve, the knowledge they produce, the questions they ask and the answers they find, will leave no permanent mark on the universe. The universe will not remember that it was understood. It will not carry forward any record of the brief, improbable moment when it contained minds that looked at it and saw it clearly. The understanding will have happened, and then it will be as if it never happened, because the physical systems that encoded it will have dissolved, and the universe that continues after them will contain no trace of what they knew. The universe is not a place that rewards understanding. It is not a place that preserves the achievements of the minds it briefly produces. It is a place that generates complexity and then dissolves it, that produces order and then erases it, that creates the conditions for knowledge and then eliminates them, moving always in the direction of less toward the final state in which the distinction between having been understood and never having been understood is physically meaningless. because there is nothing left that could make the distinction. And yet the understanding happened. Whatever the universe does with it afterward, whatever entropy does to the physical systems that encoded it, the understanding happened. The measurements were made, the models were built, the questions were asked, the answers were found. In this particular corner of the universe, at this particular moment in its history, something looked at the cosmos and saw it. Not completely, not without error, not without the permanent limitations imposed by horizon and entropy and the opacity of the early universe, but really, genuinely, with instruments and mathematics and the accumulated effort of generations of minds, something in the universe achieved a real, if partial, understanding of what the universe is. That is not nothing. It is, in fact, the most extraordinary thing the universe has produced, more extraordinary than the cosmic web, more extraordinary than the supermassive black holes at the centers of galaxies, more extraordinary than the intricate chemistry of life. Because the cosmic web and the black holes and the chemistry are all things the universe does automatically, by the operation of its laws, without anything that resembles intention or effort or the overcoming of difficulty. But understanding is different. Understanding requires a system that is working against the tendency of entropy to erase information, that is maintaining a model of its environment against the constant pressure of disorder, that is asking questions that the universe has no obligation to answer, and finding answers that the universe has no obligation to provide. Understanding is the universe doing something it does not have to do. And the fact that it does it, briefly and rarely and in the face of everything that works against it, is the most interesting fact about the universe that the universe contains. But it goes deeper, because the understanding we have achieved is not merely a description of the universe, it is a description of our situation within it. And our situation, as we have now described it in full, is this. We are temporary structures in a mostly empty universe, made of a minority component of the universe's matter, sustained by energy gradients that are being spent, asking questions about a cosmos that is moving away from knowability, in a window of time that is closing, on a trajectory that leads to a silence in which no question will ever be asked again. That is our situation, not a comfortable one, not a situation that resolves into reassurance or the kind of meaning that makes the situation feel acceptable. It is a situation that the physics describes with perfect precision and perfect coldness, and the physics does not offer an alternative. The universe is what it is, the trajectory is what it is, the silence is what it is, and we are what we are. The brief, improbable, self-aware exception to a rule that the universe enforces everywhere else, and will enforce here too, eventually, without exception. The question of what to do with this understanding is not a question that physics can answer. Physics can tell us what the universe is. It cannot tell us what to make of it. It cannot tell us whether the understanding is worth having, whether the questions are worth asking, whether the brief window of cosmic time in which minds exist and look at the darkness is a gift or an accident, or simply a fact with no valence at all. Those are questions for the minds themselves, and the minds are the ones asking them from inside the situation they are trying to evaluate, without the benefit of an outside perspective, without access to a universe in which the situation is different, without any basis for comparison except the darkness that surrounds them. We are the universe's only known attempt at self-understanding, and the attempt is failing, in the sense that the understanding is incomplete and the conditions for it are declining and the record of it will not survive. But it is also succeeding, in the sense that it is happening at all, in the sense that the universe, in at least one place and at least one time, achieved something that the laws of physics did not require, and the trajectory of the cosmos did not predict, a genuine, if partial, comprehension of what it is. The night sky is full of stars. Each one is a nuclear furnace converting order into light, spending the universe's reserves of low entropy on a trajectory toward the heat death. Each one is a temporary exception to the darkness that surrounds it. Each one will burn out. Each one will leave a remnant, a white dwarf or a neutron star or a black hole, that will cool and darken and eventually dissolve back into the entropy from which it came. The night sky is full of fires that are going out, and the darkness between them is the majority, and the darkness beyond the horizon is larger still, and the darkness of the heat-death future is larger than all of it combined. But right now, the fires are burning. Right now, the light is crossing the void and reaching the surface of this planet and entering the eyes of the minds that look up at it. Right now, the understanding is happening. The questions are being asked. The measurements are being made. The models are being built. The darkness is being seen, clearly and honestly and without flinching, by the brief, improbable, self-consuming light of minds that the universe produced without intending to, and will dissolve without noticing. Right now is the only time this is happening, not in the sense that it has never happened before or will never happen again elsewhere in the universe, but in the sense that this particular instance of it, this particular set of minds in this particular galaxy at this particular moment in cosmic history, is unrepeatable. The universe does not make the same thing twice. The conditions that produced these minds, this knowledge, this understanding will not recur in exactly this form. When this window closes, it closes on something that was, in the full sense of the word, unique. And the window is closing, not today, not soon by any human measure, but the trajectory is fixed and the direction is clear and the physics is not ambiguous. The expansion is accelerating, the horizon is shrinking, the rate of star formation is declining, the entropy is rising, the universe is moving, with perfect consistency and perfect indifference toward the condition in which none of this is possible, toward the condition in which the question of whether the universe was ever understood is a question that no physical process can ask or answer, because the physical conditions for asking and answering have been permanently and irreversibly eliminated. That condition is coming. It is not here yet, but it is coming and it will arrive, and when it arrives it will be final, in a way that nothing in human experience has prepared us to understand. Not the finality of death, which leaves survivors and memories and the ongoing processes of a world that continues without the one who died. Not the finality of extinction, which leaves a planet and a solar system and a galaxy that continue without the species that is gone. The finality of the heat death is the finality of the elimination of the conditions for continuation itself. The finality of a universe that has spent all of its order and has nothing left to spend, that has erased all of its gradients and has nothing left to erase, that has dissolved all of its structure and has nothing left to dissolve. It is the finality of a process that is completed, not ended, completed. The universe will not end. It will finish. And the finishing will be so thorough, so complete, so absolute, that the distinction between a universe that has finished and a universe that never existed will be, from any possible perspective, indistinguishable. There will be no perspective from which the distinction can be made. There will be no observer to make it. There will be no physical process that encodes the difference. The universe will have become, in every sense that matters, equivalent to nothing. The stars are burning. The void is growing. The horizon is shrinking. The entropy is rising. The darkness is patient. And somewhere on a small rocky planet orbiting an ordinary star in the outer arm of a spiral galaxy, in a minor cluster at the edge of a supercluster in a universe that is mostly empty and getting emptier, something is looking up at the night sky and asking, what is there? The answer is, less than it appears, less than it once was, less than it will need to be, for much longer, and less, always less in every direction and at every scale and across every time scale that the physics can reach, until the less becomes so complete that the word itself has nothing left to modify. The sky is full of light. The light is old. The sources of the light are moving away. Some of them are already gone, in the sense that the light we see left them before the conditions that produced them had changed, before the expansion carried them beyond reach, before the entropy erased the record of their existence. We are seeing the past. We are always seeing the past. The present is dark, and the future is darker, and the darkness is not a metaphor, and it is not a mood, and it is not a perspective that a different way of looking would correct. It is the universe. It is what the universe is. It is where the universe is going, and we are inside it briefly, looking out at it with the instruments and the mathematics and the accumulated effort of every mind that has ever asked a question about the night sky. And what we see when we look clearly enough and long enough and honestly enough is this. The darkness was here before the light. The darkness will be here after the light. The light is the exception. We are the exception noticing the exception. And the universe, vast and cold and indifferent and mostly empty and accelerating toward a silence that will last forever, does not notice us noticing it. It never did. It never will. And that, in the end, is the most unsettling thing the universe has to say about itself. Not that it is hostile, not that it is cruel, not that it is indifferent in a way that is directed at us, but that it is indifferent in a way that is not directed at anything. That the indifference is not a stance the universe takes toward us. It is simply what the universe is, in the same way that the void is what the void is, in the same way that the silence is what the silence is, complete, structural, without exception, without end. We looked up, we saw the light, we followed it to its source and found the darkness behind it. We followed the darkness to its conclusion and found the silence beyond it. We followed the silence to its end and found that it has no end, that it extends in every direction and across every time scale, and into every future that the physics can describe, unbroken and unbreakable and absolute. And then we kept looking, because that is what we do, because the looking is all we have, because the brief, improbable, self-consuming light of understanding is the only light we know how to make, and the darkness is very large, and the light is very small, and the making of it is the only answer we have ever found to the question of what to do inside a universe that does not ask us to be here and will not notice when we are gone. The universe is not waiting for us to understand it. It is not waiting for anything. It is simply continuing, as it has always continued, as it will always continue, long after the last mind has gone dark and the last question has dissolved back into the entropy from which it briefly, improbably, and unrepeatable emerged. The light is still crossing the void, for now.